go through that. So the proceedings, me and Mr. Simba. Mr. Simba is oh, let me not say fine. Will be here for only the first session and the reasons why I don't want to share with you. But anyway, we will do the first part, and then Mr. K, why are you laughing, man? Mr. K and Ms. Mukunda will do the difficult part. That's now the numbers and the operations. And you know, the two of us are scientists. We're not mathematicians. Right? Okay, so they will do the difficult part after the break. So we push 2 hours, we take an hour break. After the hour, we push another 2 hours. That's why I say 4 o'clock. Right? Okay, so please, guys, as you get your papers, we're going to look at where you have made mistakes so that you can write the corrections. If something is not clear, please help us to understand. Joshua, I want you to be here today. Eh? Come here. Norman, Joshua, come here. I still need, who do I still need here? Luther is just there. You know, it's like, you must hang more with Mauritius, right? Who do I want here? I think I'm fine. Okay. All right. Wrong stuff. Straight. Here. Not yet. Okay. Mauritius. Maria. Immediate. Sean. Here. Luther Dali. Luther Dali. Stitches. Story. Villa. Here. Rafa. Linda. Rafa is not here. Tina. Kenneth. Moses. Lucas. Manuel. Gina. Steve. Steve. Not yet. Manuel, not yet. Sorry. Charlotte. Yeah. Yarrow. Joshua. Bobby. Christina is not there. Agnes. Come with. Awesome. Okay. Right, guys. So can you please just quickly browse through your papers? Look at where you went wrong. Okay. Okay. So guys, thank you very much, Mr. Simba. As we're going through this together, those of you that don't have the paper, we have extra copies that we can give you the blank one. I know Andreas is not right. Who else is not right? Belinda and Michael. I think there should be, and Maria. There should be blank pages. I think it's in my bag. Try to check. There should be extras. I think so. I'm not too sure. Others. I think there's a bit one. Oh, two. Okay, so anyhow, what's going to happen, guys, is as we're going through the paper, you will see how we mark. We'll try to explain our marking scheme. It's not really, because to come up with a marking scheme, you have a whole thing to standardize the marking scheme. So we did not have that time, so we just did a basic one. So if we have taken marks away that should be awarded, we can come afterwards. Yeah? Let's make a note there with a pencil or so, and then we look at it afterwards. All right. So I'm already liking the vibe in the class. I can see that we are serious now. Yeah? So when we start seeing the results, we start knowing that. Okay. If you notice in this paper, there was not a lot of numbers in operation. Right? Most probably just the first two questions that we're dealing with it. This one was a bit of numbers, relationship between numbers. The second question was on upper and lower bounds. Okay. So, and then from there, straight to algebra and all the other topics. However, the first paper that you took as homework, you will see on that paper, almost more than half of that is just numbers in operation. Right? Okay, so you see how we have structured that. And most of us found the first paper a little bit challenging in the main exam last in November, isn't it? Yeah, so that part we refrain from that. We'll let Ms. Mugunda and Mr. Kemo look at it. So if you want to look at, let's just quickly admit who's R. So if we want to look at the first question, we can just browse through it, nah? So that you understand what we mean with the relationship between numbers. Wherever you see a question that deals with square numbers, these are numbers that if you have that number and you square root that, it should give you a rational number. In most cases, whatever it gives you here should be a whole number. Does that make sense? The same happens with a cube number. I think they're also somewhere down here. Yes, they actually have the cube number and a square number. So the easiest thing to do is to square root all these numbers. Just see which number, if you put a square root around it, will give you a whole number. Okay, my square roots don't look so nice. Are we together? You do that with a square. Once you're done with the square, then you do that with a cube root. Are we following, guys? Is that clear? So the number that will give you that would be this number, isn't it? All right, so then you have the 64 over there. Because the cube root of 64 will be how much? Cube root, not the square root, will be 4. And the square root, because if you put the cube root, it will give you as 4. If you put the square root, it will give you as 8. So that's the only number that can be a square number and that can be a cube number. Are we following, guys? All right. The next one, multiple of 7. What does it mean? This means back in the days, we would say these are now my timetables. Let me put it like that. So if you say 7 times 1 would be 7, 7 times 2 would be 14, 7 times 3 would be 21 and 28, and it goes on like that. So what you're going to do is to look at which number will then fall on that 7 time table. Are you following, guys? Okay, so I'm not going to try that. So I'm going to look at my memo. So the number here would then be 63, and that's the only number. Are you following, guys? Okay, and then The word product means to multiply. Are we following? So they simply just want you to find the product of 17 and 4, multiply 17 with 4. I am getting 68. Are you following that? Okay, the next one, the factor. Factor is a number that can divide exactly into that number without leaving a remainder. So what do? You start looking at the numbers you have here from 60 up to 69. So you could say this divide by 60, see if it gives you a whole number. If it doesn't, it's not a factor. Divide by 61, divide by 62 until you're 69. And then you will see which number will work there, your 62. So all of this here is just correct answer only. So you get 1 mark, 1 mark, 1 mark for that. Those are easy 4 marks. Are you following? All right. So what do we see? Factors, products, your cube numbers, your cube roots, or your cube square numbers. Are we following that? Okay. So this is how you get them. All right. Fine. The next question doesn't ask you to find the upper or lower bound directly. Are you following? It asks you to find the maximum possible volume. So if it's maximum, we are referring to the upper bound. Are we following? So with the lower and upper bound, everything you multiply or add, you can take just the upper bound. Are we following? So for us to find the volume, we have to take the area of the base multiplied by the height. This multiplication. So we just need to take the upper bound. Are we following? After answering this question, I'll show you where you need to consider upper bound relating with the lower bound. Are you following? Okay, so in this question, we need to first find the upper bound for this length. We need to find, or the width rather, and then the length here and the height. So they don't tell us to the nearest, say, centimeter or millimeter, but it says to 1 decimal place. Are we following? So this part where it says your 1 decimal place, you say 0.1 decimal place, and because you're looking for upper and lower, you divide that with 2. Are you following? So if you do that, that will give you 0.05. So that 0.05 is what you add and subtract for your upper and lower bound respectively. Are you following? Are we all together? Okay. So once you have done that, I see Mr. Katema and Ms. Mugunda normally comes up with a table. But since we're just looking at the upper bound because they're asking the maximum, we could just simply just add the 0.05 to each one of them. Are we following? So for the 9.1 plus your 0.05, that was giving me 9.15 for this part over here. And then we have the 14.3 plus then the 0.05 must now give me what? 14.35 for this here, the length over there. Are you following? And then the other one would now be your 2.4 plus then the 0.05 will give you what? 2.45, isn't it? So these are all the upper bounds for the different dimensions for that cuboid here. And then these two, the 14 and that are for the area. You multiply those two, I think the top ones. As a matter of fact, you multiply all three of them together. Does that make sense? The common mistake here was that some of you just multiplied this as it was. Just say 9.1 times the 14.3 times your 4. That is wrong. That is as it is. That's not when it's possibly expanded. Are we together? So if you do that correctly, you get a long number. So it's the 9.15 multiplied by 14.35 multiplied by 2.45. This was giving me a number of say 6911125. The instruction on the front page says what? If it's not exact to 3 significant figures. So some of you, when you rounded it off here, 1, 2, 3 figures, you left it as your 3, 2, 1, which is wrong. Are we following? So you look at this value here after the third significant figure, it's more than 5. 5 or more will change this. Are we following that? All right. So the correct answer will be 322 centimeter cube. They already give you the units there. Are you following that? Okay. So where do we get the mark? We get 1 mark for showing all those conversions there, 1 mark for multiplying for the volume, 1 mark for the final answer, and those are our 3 marks. Yes.
So on the instruction, please,
But there's no angle here. Angle size. It's not angles and sizes, it's angle size. And for money, it's 2 decimal places. Are you following? So whenever you're dealing with an angle, 1 decimal place, money, 2 decimal place, anything else, 3 significant figures. Yes. Correct to 1 decimal place. Okay, listen. It doesn't say the final answer should be 1 decimal place. The fact that they say the maximum or the minimum, that tells you need to find the upper or the lower bound. So the upper and the lower bound, sometimes they can say correct to 1 centimeter or 5 centimeters. So that 1 or 5 centimeters is what you divide by 2 to get this value here, so that that will now be added or subtracted from your for your upper and lower bound. This is not, and it's a common mistake. It's actually good that you raised that, because we would think that your final answer must be 1 decimal place. They say find the possible maximum volume of the container. Now that possible maximum volume as reference to what? With reference to 1 decimal place. If they had say 2 decimal places, you would have said 0, 0.01, because there are 2 after the decimal. And that you would have now divided by 2, you get to 0.005, and that will now be added and subtracted for the upper and the lower bounds respectively. You understand? It's not the final answer. Is that clear? Okay. Any other question? Good. Right. So we go over. This is very straightforward. Yes, please. It's on the same question. Oh, yeah. I forgot about it. Thank you very much for that reminder. All right. Remember last time we were looking at when is it that you now need to multiply upper with upper or lower, or when do we know based on the structure of the question or whatever we are looking for. So I'm going to use, let me think first. Let me try to use an example that you can relate to. Let's just try to clear this out. Just give me a second. Okay, so for example, I told you that sometimes it depends on the type of question. Let's say, let's maybe use a different color so you don't confuse with the group. You see, I told you that whenever you have to add or whenever you have to multiply, you only use the upper bound. But when it comes to subtraction and division, that's when the combination differs. Are we following? So depending on what you have. So say, for example, you've got a scenario where you have to calculate the maximum possible speed or the minimum possible speed. Now, for you to find speed, you have to say the distance that was covered over the time you took to cover that distance. Are we following? So now what you will do is your distance, you get your upper and your lower bound, depending on, let's say, to the nearest kilometer, for example, you divide that kilometer by 2, and that 0.5, you would now add and subtract for you to find your upper and you to find your lower bound. Are we together? And that will only be for the distance. The same applies for the time, right? They could say to the nearest minute or to the nearest 30 seconds or whatsoever. So that one now you also divide by 2, and the answer you would add for the upper bound and you would subtract for the, lower bound. Is that making sense? Now, for you now to see, where will I get the maximum speed? You need to have the awareness of a fraction. Where is the fraction the biggest? When the denominator is small and the numerator is big, isn't it? For example, I give you 2 fractions. Let's say we keep the numerator constant with the 3 fractions. So I am making the denominator big. Let's make it a fraction. Let's take it as 5, for example. All right, let me take this one out. Right, so now I make this 5 and I make this, say 2, and I make this, let's make it 10, for example. Right, so what am I going to get here? You see what's happening to the numerator here? Actually, let's make it 1 so that we can decrease the numerator from 5 to 2 to 1. Right? What will the speed be for the first one? Let's say this was the distance that was constant at 10 kilos. The time was 5 minutes, 2 minutes, and 1 minute. So as you have a bigger one, this will be 2, say, meters per second, for example. And this will be what? 5, and this will be 10. What happens if your numerator gets smaller and smaller? The speed gets more and more. So which means for you to get the highest speed, you must use what? The lower bound, because they are the smaller ones. Are we together? The opposite can apply. What if you have to find the minimum possible speed? That means that up here, even if you keep the denominator constant, this guy now has to increase. You get what I'm saying? It is based on the formula. So it's based on the question. Maybe I'll try during break to find the question to demonstrate it. But you understand the concept? Is it clear? Okay, so it depends on the scenario that you are having. Where will I mix the lower and the upper bound? And it's normally in fraction form, or because fraction form deals with division, and normally in subtraction. You understand? So that deals with now when you will have to mix with that. Yes, Mauritius? Okay, perfect. All right, so let's go here. We simplify. I think this was very straightforward. If you have this in front, you multiply with each of the terms in the bracket. So 2 square multiplied by that would be 2x cubed, isn't it? And then 2 multiplied by that, 6 multiplied by, will now be 6. How many x's do I have? Only 2 of them, and then my y. That's the final answer. Now, the tricky thing about this question is only 1 mark. That will be only correct answer only. We don't even look at your working, expanding, anything here. So if you have maybe one of these terms that you are having here are wrong, you don't get any mark there. Does it make sense? Okay, so that was an easy mark there. You've got 2 brackets. They're asking you to expand. What does it mean? You have to multiply this with each of them, and then maybe we use a different color. You have to multiply the whole of it. Now, actually, I should put it like this, that you see that you are multiplying the -1 there, all right? The whole of the -1 you multiply with that. Does that make sense? Okay, so what will this give us? 2x multiplied by that will give us what? Maybe we write it here, 6x, right? 2 multiplied, yes, perfect, thank you. This times that will give me what? Plus 10x. This and this will give me a -3x. This negative and 5 will give me a -5. What do you see here? Like terms, same basis, same powers, right? So you will simplify that one. 10 minus 3 will give you a 7x. I've got my 6x squared. It's a +1 minus the 3x. So in this case, we will give you, is it 5? Oh, why am I having a 3x? I'm repeating the 3x. Sorry, that is my bad. So it's just a -5. That's correct. So when we give you the mark over here, we will give you the mark because we want to see that. That is very important, right? Okay, you're expanding, and this 1 mark for the final answer. Again, it might be different from most probably what do you call this? Your marking scheme that you are having. Are we together? All right. Are we all fine, guys? This question was very easy, but not nice to mark, because we had so many terms and elements in the set altogether. So it was not a nice question to mark, but anyway, maybe they could have put maybe between 20 and 29 or something in that case. But unfortunately, that's not the case. So this question was taking us average of 3 to 4 minutes to mark one script. Yeah. Okay. But anyway, so here you are told that the universal set, which is also sometimes denoted by this special E type of shape, is that X, right? It contains X such that X are natural numbers. Are we together? That are strictly less than 20. The fact that you have strictly less than 20 means that 20 is not included in it. Are we together? So you will count from what? 1 up to 19. Are we together? When we had to include 20, if I had this, are we together? Less than or equal to 20, then you would include the 20. Does that make sense? We don't know what we'll get on Monday, so just know that as well. So if you list those elements there for that set, it will be 1, 2, 3, up to 20. Is that correct? No, because 20 is not included, so it will just go up to 19. Does that make sense? Okay. Now, with that said, they are saying that is a universal set. That's everything in that set. Are we together? Which is normally with that rectangle, then you've got your universal set. So everything within, including those ones that are in the set, whether they are together or whether they are overlapping, doesn't matter. Are we following? Then they tell us we've got two sets, A and B, whereby A is having your elements, right? The elements M are all square numbers that are strictly less than 20. So those square numbers have to be part of that universal set. Are we together? So those ones will now be, let's start exactly 1, 4, 9, 16, and that's it, right? Now, some of you are doing this 1, 4, 9, 16. Some of you are even just putting 1, 4, 9, 16. This is wrong. Because set notation and set language, that's what the topic says. How do we note down the elements of set in curly brackets, and then you separate them by using your comma? Are we together? So if you have written this, it's wrong. It's just one mark there. Yeah? So if you have it wrong like that, please make a note there. We penalized you for not using the curly brackets or not using the commas to divide the elements between the sets. Are we following that? Okay, so we start here with the curly bracket, 1, 4, then a comma, then your 9, and then your 16, and then you close off with the curly bracket. This is fine. Even if you now come and put set A is equal to that, that's also okay. But this is really not necessary because we already have it like that. Are we together? And sets are represented by capital letters. Are we together? The elements in the sets could be capital letters, it could be small letters, lowercase or uppercase, it could be the words, it could be shapes, it could be anything. It's not limited to anything. So when you put that, you get that 1 mark. And B will be even numbers such that they are all less than that. So if you have list from 1 up to 19, you get the even numbers there. So we start with a curly bracket. It would be 2, separate 2 from 4 with a comma, right? What's the next one? 6, 8, and what else? 10, 12, 14, 16, and 18. So those are all even numbers. Numbers that are divisible by 2 or can separate into whatsoever, right? Are we all together? Is that clear? Again, 1 mark for that. That's why I'm saying there are so many elements to miss for 1 mark. Because if you miss 1, it's wrong. Because it's only correct answer only. You understand what I'm saying? So that was my issue with this question. But anyway, that's just an opinion. What does this sign mean? The intersect. What they have in common. Are we together? What do these two sets have in common? Something that's in A that is also in B. Now we've listed set A in question A here and set B here. So if you look at what is common, maybe we use a different color for that. What is common here? 4 and 4, right? What else? 16 here and 16. So that's what they want you to list. So you list what is common in both those sets. All right, so you will say now, curly bracket, 4 divide, the separation, not to divide, the separation would be like that. So you get your 1 mark if you do that. So please understand that this sign, we refer to that as your intersection. Are we together? Where they have that in common. This already tells you that set A will intersect with set B. So if this is A and this is B, what they have in common will be the 4 and the 16, because it belongs to both, right? Common space in your house is what? Your bathroom, your kitchen, your sitting or living room. Are we together? That we all can share. Sometimes our rooms are not so, for our parents. But anyway, some of us are demanding on privacy. Okay, what does this mean? This means union. When something is union, it's all together. Are we together? United Nations means all the nations together. So you will list everything that is in A and B, but do not repeat. Does that make sense? Are we together? Everything that is in A and B, but do not repeat. So literally, you have everything in A and B. So you go here, A and B. So I've got 1 over there, so I can start with a 1. And I have 2 over there, so I have the 2. And then what else? Do I see a 3? No 3. Then I've got the 4, right? So the 4 is also out. What else do I see? 5? No 5. 6 is there. So I've got 6. And what else? 7? No 7. 8? 8 is there. 9 is there. 10 is there, 11 not there, 12 is there. What else? 14, 15 is not there, 16 is there, and 18 is there, and that's it. For 1 mark, guys, just leave out 1, it's wrong. You understand? All right, so that's the union. So which means the next part is everything in A union complement. What does that complement mean? Without that. Are we together? So you need to go to the universal set and list everything without the union of A and B. That's what it means. Are we together? When you have the complement of A, you list everything that is there without A. That's what it means. So if you want, you could maybe make a note there to say this means without. Generally, a lot of you did well with this question. It's just a notation. Nah? Okay, you really did well. Okay, so you can see. So in this case, everything without it. Now we know this thing ranges from 1 to 19. So 1 is there, right? Everything without that. 2 is there. What's not there? 3. Oh, no, it's not easy to make curly brackets now. 3, 4 is there. 5 is not there. 6 is there. 7 is not there. 8 is there. 9 is there. 10 is there. 11 is not there, right? 12 is there. 13 is not there. It looks like these are all odd numbers, no? And then you've got your 17 and then your 19. So this is what you have, which we will read as the 15. I left out 15. Okay, so we will then put in 15 here and then put the comma over here. Is that clear? Okay, so that part is fine. And then all you have to do is now to take the information from A up to E and then you plug it into your set notation here in terms of its drawing. Are we following? So remember, A and B, the union was this, isn't it? And A was having only square numbers. So 2 of them are already there. So the 1, the 4 is there, the 9, and then the 16. Are we together? And on this side, on B, we had everything, right? Except what? Because these are all even numbers, right? So it will now be 2, 4 is already there. You can't come and put 4 there because this thing shows you that this is already part of B. Does that show you, right? And then on the other side, also the same thing applies that this is already part of A, the common space that you are sharing. So do not come and list it twice, okay? Now with that said, we can now continue. And what do we have? 2, 4, 6, 8, 10, 12, 14, 16 is already there, né? And then your 18. And then you look at everything that is not in A and B will be outside A and B, which will be within the boundaries of the universal set. Are we following that? So what is that now? 1 is already there, 2 is there, 3 is not there, 4 is there, 5 is not there. Basically, it's everything that you have. It's telling you without the union of A and B. So all that we have there, 5, 7, 11, 13, 15, and then you're 17, and you're 9. There's no particular order to put it as long as they are in it. Does that make sense? Yes, Gift? If we have made a mistake, just make a pencil, we'll give you your mark. Okay. It is the same question. All right? No, I'll give you the mark now. I'll show you where we award the marks. So the marks were awarded for having the correct A. All of A, 1 mark. All of B, 1 mark. If you missed 1 term or 1 element there, it's gone. You understand? And the 3rd mark was having the correct ones in the, outside of A and B in the universal set. So that's how we awarded the 3 marks. Is that making clear? Because if you have A and B correct, your intersection will obviously be correct. Does that make sense? So that's how we awarded the mark. I think that is clear now. Né? You might have missed 1 term somewhere. Okay, so I know it's very easy to make those mistakes because it's so many terms. Né? Try to scratch them out as you're listening to them. Yes, Shakira? D, okay. D, we say A union B. It means everything in A plus everything in B. So the U, you can say that this is union. You can maybe see that it spells union. So this is everything together. You watch that movie, Everything, Everything. Right? You watch that movie? Yeah. You know, my wife doesn't want to, she didn't want to take the boy outside after he came home, even now after 6 months. She said, you see what happened to that girl in that movie? And the boy, like, I'm not racist, but you will see white babies. Yeah? On the second day, no socks, nothing. Just stay in the mall. Now we would cover them up. Oh, this child cannot take, you know, they will suffocate in the wind. I remember my wife said, sorry, so union means, Shakira, you add it together. So you will take everything in set A plus everything in set B, but without repeating the elements. So if there was say 1, 2, 3, and there was 3, 4, 5 here, the union will just be, the union of that will be 1, 2, 3, 4, 5. You will not repeat the 3 twice, only list it once. Does it make sense? E.
No, what does the thing after the D?
Still at D.
Yeah.
It reads as A union B. This is just a comma. Like to share, you are going over to the next question. That's why they have a full stop. The questions are done. Okay, the comma, the only thing you might worry about is the complement. Yeah? I think you understand the complement. Okay, that's just a comma. It's not part of the question. It's just like grammar, I guess. Okay. Yes, my people online, are we fine?
Yep.
Someone ready?
Yes.
Yes. Okay, you lowered your hand. Okay. Eleni, we are missing you here. What's up?
I would just decided to stay home. Woke up late.
And yesterday, what happened with the mock exam?
I had a hair appointment because I cannot go to school with dyed hair.
Okay. All right. No problem. We've got a ball to pick there. Okay. Right.
Excuse me?
So I will see you. I will see you later today or tomorrow. Okay. So anyway, here we are given that this equation, guys, we feel like that. If it's not, I will enjoy my Sunday. Seriously, I'm not the one to write this then. So I don't feel any pressure. But if you want to come, we can still go. Okay? It's up to you. So we'll still talk about it later. They're saying making B the subject of the formula. What does it mean? Make B the main guy. Put the spotlight on B. You understand? So we want B to be alone on its own. That's why we have it like that. But now we need to apply a lot of different operations here. Né? The way you remove things is to apply the opposite. If it was multiplication, you divide. If it was addition, you subtract. If it was square root, you square. Those are the 3 things that we can look at all together. So where is V? V is in here. So if you have different ways, you could say, let's first get rid of the T. All together. So we've got the T here. B minus that squared is equal to the K. How do we get rid of the T? By dividing both sides by T. We divide T. So the T and the T will cancel out together. And then this will then result into B minus the C in brackets will now be equal to K over your T. Are we understanding? Is that clear? Now we still have a square there. So how do we get rid of the square? The opposite of square would be what? Is to square root. So I square root both sides. Whatever I do on one side, I must do to keep the equality. Are we following? So this and that will cancel out. What will I have now? B is V minus that will now be equal to K over T square root. Are we following? We're almost there. How do I get rid of a negative C? By adding a C on both sides, because these two will cancel out. Are we together? So in other words, what is left is that B will now be equal to K over T, the square root of that plus your C. That's the final answer. How do we award the marks? I'll give you 1 mark for dividing by T. I'll give you 1 mark for showing that that square root gets out of the way and maybe that, and then 1 mark for the final answer. So basically you'll get 2 marks for your method. It depends on wherever, and then the final answer, your 1 mark. Yes, Rosa? In front of that, yes, that can be very true because you are getting the square root of it, but you might not be penalized for that. Nah? It will be if they want the exact value of it. You understand? Even if they have to write it like that, sometimes have you seen that if I say x plus y is equal to the square root of b minus c, I don't write it like that in the equation. You get what I'm saying? It's only when I start solving that I can consider that, especially if you get the exact value. You understand? So yes, if you write it like that, that means you have completely answered the question. But I don't think that we will penalize you if you don't have it there. I don't think we penalize anyone for that. No? Okay, is that clear? Right. So now we've got that over here. Let's see the chat box. Will it be wrong if I just put the square root on the k? Yes, it will be wrong because remember you had the k over the t on that side and you had the b minus the c squared. So you were square rooting the whole of that term so it can cancel. So this whole term has to be squared. I mean the square root of that. So if you maybe just put the k square root over the t, yes, it will be wrong because even if it was a fraction and you do that, this here is not equivalent to that. This is not, sorry guys, it's not equivalent to that. So yes, Alice, it will be wrong if you do that. So you have to put it over the whole term. It's almost like if you had something like this, x plus y, and you just put it here, it's wrong because it will only square root the x altogether. So you can maybe have to over both of them, right? Whether it's a fraction or whether it's in the form. Right, yes. Oh, yeah. But even in that, let's say, because Mauritius is saying you might have started like this. So you had the square with a t equal to k over the t. So you wanted to get rid of the square root. So you have to put the whole of that under the square root, which means eventually the t had to be squared. I would get rid of that part. You understand? So you say, sorry, there was no t here. Yeah? It's just k on that side because you didn't divide it yet. So you have it like that. Let's say you had to approach like that. Right? So what will happen here? This will still cancel out, and this will still cancel. It's like we're just back at the same thing. Sorry, it will not cancel. So we'll have something like this. B minus that equal to the square root of k. So we go further now. Sorry, this is out. Yeah, sorry. Pardon? Exactly. Thank you for that. So that will still be part of that. So eventually you'll come to the same answer. Okay. So the next one, we just have to substitute. Now, so you already have the expression, and they are telling you that you need to find the possible value of v if you are given this scenario. My people there at the back, are we following? Seems like I have to drink water or something. Okay, so we had this situation, k over your t plus your c. This was square root, everything there. They are telling us the following now. They are telling us that what if your t is equal to 100 and your c is equal to 250 and your k is equal to 10,000. So your k is 10,000, your t is 100, and your c is that. So you substitute that, isn't it? So here your k will now be 10,000 over your t, which is 100. All of that has to be square root plus then that 250. You understand? So that is what the value of v will be. I don't know if you do that correctly. I am getting what? Yep, 260. That's the correct answer. Mr. S, please help me with the time there so that we don't, at least by half past, I want to go through this. Second, say 10 plus 2. Yes, because this will eventually give you 10 if you simplify that. So if you just punch it on your calculator, it will still give you the same answer. All right, factorize completely. When you have, sometimes when you have 4 terms, look at difference between 2 squares somehow, but first thing is to group them. Yeah? Group the like terms that have something similar. So this guy has a y in it, this guy also has a y in it. So I'll put the 4y plus the ky. Are you following? And then on this case,
are we allowed to rearrange them?
Yes, you can. It's like you're telling plus 3 and you say 3 plus 2 will both give you 5. You are allowed to. You should actually rearrange it to make it easy for you to see them. Yeah? The only problem I have with the rearrangement is that sometimes we forget to take them along with the signs. So you see the 12 had a negative sign and then the other one had a negative one on there. Guys, if there's something, we have Mr. Simba and Mr. Akatimo here as well. If I'm too far, something is not clear, you can consult me. Is that clear? But this video, you can always go and look at it on YouTube again. Yeah? We have it there. I'll share the link after the class. Okay. So if you rearrange them, you can see that the common term here will be y. So taking the y out will now 4 plus then your k. Are you following? And here, what's the common term here? You don't see a variable that's common, but you can use the factor. 3 can divide into both. So you could take out it with a -3. And then it means that multiplying a -3 with a 4 will give you the -12 here. And then multiplying with a +1 will give you that. What do you see here? When you have two of the same brackets, you just list them once. Are you together? And then on the other side, what's going to happen is that this coefficients in front of the brackets with their signs will form the one bracket. Are you following? So the one bracket, you will take these two things together and you say y minus your 3 in brackets. And then the other one would be listed once multiplied by 4 plus k. For those of you that want to see if this is true, go and expand the two brackets and you will get back to this. Does it make sense? That's the method of factorizing by using common factors, by grouping them. Is that making sense, guys? Are we together? Yemo. Are we fine? Can I move on? Yemo. What we're doing in terms of the brackets one. By grouping. Okay, look here. If you factorize, what's happening now? Oh, I'm on the eraser. If you factorize by grouping, look at this. If you have ax squared plus by minus maybe, say, I need to think now, what can you get? A minus a, I'm finding something. I want the a need to be, and then minus what? Maybe we could put the a with a y, and then we would minus it with dx would work. Okay, so give what we have here is, if you have, mostly when we have 4 terms, that's just a hint. It's not always the case. If you have 4 terms, look into grouping them. So what do you see here? This ax is common with this. You understand? Because here I've got my a. Here I have that. Actually, this x is a problem with this. Okay, but anyway, so if we solve this over here, you would group them next to each other. This one minus that. Are you following? And what do you have in common here? The a. That's why you are factoring the a out. That's the concept. But I'm not sure whether this will work. So what we did here was we grouped these two things together. And then the minus 12 and the minus 3 were together. Are we following? So once you group them together, this is what we have. 4y plus your ky minus your 12 and then your 3k. You see, even though I move this 12, I move it with its sign. The same with the 3. Are we together? So now here at this point, what you're now going to do is to see these two terms that I put next to each other have something in common. What do they have in common? The y. So that is what I'm now factoring out. So I'm going to take the y out. And then I understand that this factorizing, you should understand, right? So I need to multiply y with something so that I get the 4y. And to multiply that, the 4 is the k. And then I need to multiply the y with something to get the ky. And that's it. Are we together? Yes.
So, sir, if I chose like the ky minus the 3k, then I would like put the k out and then put the other.
Yes, we can actually do that. We will do that now. Okay. So in this case, because you group this, you took out the common factor, which is the -3. Okay. And then you have your 4 plus then your k. Let's say, because the k is in common, you took it out like that. Let's do it like that. So now you said your 4y minus your 12 are now grouped together. No problem. And then you group together now your plus ky with the minus 3k. What are you taking out here? You're taking out the 4, isn't it? So when you take out the 4, what do you have here? Y. And then this would now be y minus 3. Perfect. And here, what will you have? What are you taking out? You're taking out the k. Now, when you take out the k, what happens? You've got the y minus the 3. Okay. Is that not the same thing we had? The same thing. So that bracket here, you will now repeat as just ones. And those ones, the coefficients, you list them there as 4 plus k. Those brackets are multiplied, which is exactly the same thing. So it doesn't matter which way you are taking. As long as they are having something in common, it will boil down to the same answer. Does that make sense? Okay, perfect. Right. So this part is fine. The next question is a little bit interesting because this is where we apply the difference between two squares. Yeah? But now, once we have only variables, this applies to variables that have got even powers or even integers or integers or exponents or whatever way or whichever term you want to use for them. Are you following that? Are we all together? All right. So with that said, let us look at what we're given. We've given your your a squared and your, okay, let me just finish it and you can look at it. Right. So what we are looking at, just to avoid some confusion. I think people online, can you see the screen properly? Is it big enough for you?
Yep.
Okay. So here what I mean is if you only have variables, look at even powers. If they give you numbers, you look at perfect square numbers. Are we together? So now what you're going to do is, because it's variables, they've got even powers and they must have a negative in between. If it's a positive, you can't do anything. Are we following? So when you do the difference between two squares, we know that we get two brackets, isn't it? Of which one bracket would have the positive and one bracket would have the negative. And then you halve each term, the integers, the powers, right? So that will now be a squared and your x squared, because they were 4, they are half now. Are we following? And then what will this be? B squared. And the same will happen here, a squared, your x squared, and your b squared. So now again, you do have powers that are even, isn't it? So these are even powers. So I can also apply the same method again, but it will not work for the first bracket because of the positive. It only works for negatives. Are you following that? Okay, so the first bracket will remain the way it is, plus your 2b squared, and then this one will now be expanded. You will again have your two brackets with the one for the positive and one with the negative. Are we following? And then the powers will now be half. So it will be this and that, and then this will just be that, isn't it? Ax and your b. I can't do anything here because my powers are not even. My powers are now 1, 1. Are we together? Odd powers don't do that. So we have this, and then we have those two brackets over there. So you can put this in the bracket. Remember, you're factorizing it now. So you can have your ax plus your b, and then you've got the third bracket, ax minus your b. Does that make sense? So that's your final answer. So we were getting marks for each of the correct ones. Yes.
They were all like to the power of 3.
You can't do anything if you were starting with power 3, x to the power 3 minus b to the power 3. The fact that they have odd powers, it doesn't apply, especially because they are variables only. This only applies for even powers. Does it make sense? Okay, yes, Chance? We are saying that this difference between two squares that we apply, where one bracket has a negative and another bracket has a positive, only applies when we have even powers. Pardon? Oh, you mean what I wrote down here? Okay, let me try to explain it here. We have a to the power of 4, x to the power of 4 minus b to the power of 4. Are we together? So how do I know when to apply difference between two squares? If they are variables only and they've got all of them got even powers, even if this was say 6, for example, it's still an even number. You still do the same thing. Are we together? So when that is the case, you will have two brackets. You know that is common in your difference between two squares, right? Is that making sense? Like, and then the powers will be halved. It's like you're dividing by half, you're dividing by half. So one of them would now have your x to the power of 2, I mean a to the power of 2, x to the power of 2, and your b to the power of 2. The same applies. The brackets are actually identical. It's just that one of them have a negative and one of them have a positive. Does that make sense? Yes, Eleni?
Sir, please scroll up just a bit. You see the last two brackets that you wrote after a squared x squared plus b squared. Would it be wrong if I only wrote the last two brackets
Yes,
as my
because
answer?
you are excluding this guy. This guy is still part of the factorization. Because if you go and expand these brackets and you go and simplify the like terms, it must bring you back to the original question. Not this one, but it must simplify to the original one. So if you exclude this bracket, this will only give you this part.
Okay.
Okay, so you need to list all three of them.
Okay, thank you.
Yes. So chance, why are we dividing by 2? The law says that if you are having even powers, look here, if you had, how should I explain this now? If you had even powers, the way you do the difference between two squares is you need to come down and halve that. If this was a to the power of 8, you would still halve that. You understand? It's a law. Does that make sense? And then you would only continue with that wherever you are seeing a negative sign, because only the negative one, the y behind that is the following. If I had a raised to the power of 2 minus b raised to the power of 2, right? This will be equivalent to the two brackets, okay? And then I will have a plus b in one bracket and a minus b in one bracket, right? Which means that if I now multiply these brackets, I expand them, I simplify that, it must bring me back to this. That's what it means, right? So if we do that, what are we going to have here? A times a would be a squared. A times b, negative b would be negative ab. B times this will be a positive ab. B times negative of that would be a positive, a negative, no? Sorry, this would now be a negative over here. So let's get that back. This will be a negative b squared. These two are like terms. Negative ab plus that will cancel each other out. And at the end of the day, I would just have this, which is the same as that. You understand? Do that with a positive 1. Do that with a positive 1. So which means that if we want to say, okay, it has got two brackets, one positive, one negative, which will be the same, expanding them will give you that. This one, a squared plus b squared is not a squared minus b squared, because if you expand it, this is the answer that you get. But in this case, you get the same answer. That's the proof behind it. You understand? If you want to see that, and if you want to go further, go and put the 4 plus your, why does this thing not have an undo button? Okay, guys, one of the tasks that I want to give you is find us programs that will work nicely. Yeah? Okay, this over here. Okay, so this is after the exams, guys. So this is what you have. Yeah? So if you say that this is the same as your a squared minus your b squared, and then your a squared plus your b squared. Of course, this can still go further, right? And you go further and you say a minus your b and your a plus your b and the whole of that, a squared plus your b squared. I can't go further. If you expand these brackets, multiply, it will get back to that. That's the proof behind it. So when you ask a question, but why 2? Go and try it out and go and do it with a cube number. Say a cube minus a b cube and see if it gets you back to that. It will not be equal. That is why only the even numbers are working. That's the proof behind it. Yes.
So I wanted to say if it was like minus b.
Yeah, b to the power 4.
If it was a plus b4, then both brackets would be plus.
No. Guys, it doesn't work. A to the power of 4 plus b to the power of 4 does not do that. It does not do that. It's only the only thing that qualifies for the difference in two squares is if you've got a minus and you've got even powers there. then one would have a positive and one would have a, oh, that's the law. It only works with a negative and squares. It only works with that. There's nothing like for positive b, it will be like this or not at all. Are we together? If you had common terms, you would have taken out a common term and factorized by that. If there's no common term, you can't factorize it. You need it like that. Agnes?
So, the answer is
Three brackets. The same thing that Eleni was asking. So I just need the three brackets, which we had as your A. Okay. So the final answer will be A to the power of squared, and then your x squared plus your b squared. That's your first bracket. And then the other bracket would be ax minus your b, and then your ax plus your b. Those are the three brackets that we want to see. Does it make sense? Yes. Order doesn't matter. It's almost asking does 2 times 3 or 2 times both of them will give you 6. No. Listen, you are multiplying terms. They are in brackets. Are we together? Or do you mean the arrangement here? You mean do I first put the negative one and do I first put the positive one? No, it doesn't matter. It's like you are saying multiplying a negative number with a positive number or multiplying the positive number with a negative number. They will both give me -6. That is, those are the ways that you prove. If you have a doubt, prove it like that. Does that make sense? Yes.
So you can only simplify with negative.
Only, and it must be even powers. You understand? You could also do that with, let's say you've got 4a squared minus 16b squared. These are perfect square numbers. So you will have your two brackets, right? You will have your square root of 4, this plus then the square root of 16, 4b, and on the other side, that with just a minus. That's your final answer. If you don't have coefficients, it's fine. Then this should just be even numbers. But if you have coefficients, it must be perfect squares because you want this to be perfect. You want them to be integer. That's another way of difference between two squares. Does it make sense? Okay, perfect. This question shows a cube. They want us to know the vertices, the edges, and the faces. What do we mean with vertices? The corners, yeah? How many corners do you see there? So if we draw the three-dimensional shape here, this is what it will look like. How many corners do we see there? 1, 2, 3, 4, 5, 6, 7, 8. 8 corners. Are we fine? Okay. Edges. What are edges? Edges are the boundaries, right? Between the faces. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 edges. Does it make sense? All right. Faces. Faces are planes. Okay. How many planes do we see here? Just that this thing doesn't want to work with the highlighter. Now, this front face is 1, and then the back one is another one. There are 2. The side and the other side, 4. The top and the bottom, 6 faces. Yes. Make a point, man. We're going up. Yes. Edges are now boundaries. Yeah? These are now your boundary, say, between the faces. Faces are the planes. So this first face and the second face is bounded by an edge. Like it says, the edge. You understand? So those are the ones. Uri, are you following? So correct answer only there. This is one of the things that are very close to my heart. This is actually one of the Platonic solids. That's where the name of this academy started from. There are only 5. That is now the cube that we have there that we call the tetrahedron. another name for it. Okay, so we do a lot of that faces and what. When I was teaching at Balrog, we used to mold those shapes with what is this, with clay, and that's where the motivation came from. Right now, guys, I've got a problem here. Some of you are estimating this thing. Mr. Simba, could you maybe please just in that 1, 2, 3, né? That's a math teacher's class. Maybe she's got that compass, né, for the board. Maybe just check somewhere in the cupboard. If we don't find, we can just try to explain it free-handedly. Yeah. So, guys, the question says to construct. What does that mean? We want to see the construction line. We want to see those arcs that you are drawing with the compass. Don't rub them out together. We want to see the exact ones over there. So what do we have here? We need to construct a triangle. So if I could show you here on the memo, I don't know what question is this. Question 6. Okay, it's over here. So if you see, those of you that are a little bit far, the marks that you are getting are for the construction. Those are the marks that you are getting. So whilst Mr. Samba is seeing if we can find, what I advise you to do is to draw a rough sketch, a small rough sketch first. Right? So what do we have here? We've got a triangle. Are we together? You can later rub it out. Nah? So this triangle has got X, Y, and Z. You could also have your triangle like maybe this was your Y and this was your X. It doesn't matter how your rough sketch looks like. Are we together? So all that matters are now the dimensions that you're going to put on your rough sketch so that you can see it easily. Now we are telling you the distance between X and Y are 8. So between your X and your Y are 8 centimeters, right? Please, guys, this is not your construction. This is your rough sketch, né? Please. All right. And then the distance between Y and Z are, what's the distance there? 7. So from Y to Z there is 7 centimeters. And then obviously from X to Z now will now be 6 centimeters. So this is a rough sketch, but if you take it to reality, it will look like the 8 will be a little bit longer than the 7 and then the 6. It looks something like this because this is 8, this is 7, this is 6. This is where we apply common sense. Yeah? So if you construct it properly, this is what it must look like. Is that clear? And then if you construct it perfectly, all your triangles, angles inside must be equal. What I mean is not equal in the sense that, they are all 60, for example. Like if I take JJ's paper and I take Joshua's paper and I take Mamsi's paper, I must get the same thing. Does that make sense? All right, so we've got one there. We have not really tried it on an LED screen. So maybe it can work because it has that. Okay, it might not, because I wanted to see if we could get the pen on here. Okay, maybe this can write, isn't it? Okay, what about this? That's all right. It doesn't identify it as that. Okay, so the guys in front of me. Okay, yeah, maybe. No, but then I can't write because I thought that this hard thing can just like a finger could write, yeah? So I can still not do it. I think it picks it up as I don't know. But anyhow, let me try my best to explain what is going to happen. I'm going to take a different color. Maybe we could use this one. I don't know which color do you prefer, maybe a darker color. So what I advise you to do is look at the base. You need to start with the base. So draw a line that is more than 8 centimeters. Are we together? So you take your ruler and you draw a line, a straight line that is more than 8 centimeters. Then you take your pair of compasses, put it in, the pencil in, and then you open it up and measure exactly 8 centimeters. So what do I mean with that? Just to accommodate the people online, if this is your ruler, what's going to happen here is your sharp end will start at 0, and then you open your compass, and then where the pencil is will go up to 8, so that you have it open at 8. Then you put the sharp end here on the line. The reason why you draw the line a little bit longer is because you're constructing that. All right? Oh, okay. So if this is your point, this was open. So where you make your arc, that will be exactly 8 centimeters from this point up to this point over here. You understand? right? You could even go back and put it on this point over here and go back and it will exactly make an arc there. What does it mean? You have constructed the line that is exactly 8 centimeters for your X and then for your Y. Label your point. Are you following that? All right, now you're going to start from X. So this is your X and you want to go to Z. Yebo. Are we together? Are we going to construct? You've got your tool. Okay, so we have that first part. Then the second part, go back to the ruler and you put at 0, open up to 6 only because now we are going from X to Z. We want this line here. So you put the sharp end here and then you make an arc. So wherever that arc is, it's 6 centimeters away from there. But you don't know, is that 6 here or is it here or is it here? It is all over from this point. Remember in low-key, if you go all around, it's just the same, right? But you don't finish there. You now need to go get the one from your Y to your Z that is 7. So you go and open from the ruler here, sharp end here, open up to 7, which will be between 6 and 8 will be 7. Your pencil is there. Then you go to Y, put your sharp end there. Oh, it's already opened up, and then you come and do arc. Sorry, guys. And then you come and make your arc here. Oh, you put the pencil down. Why are you doing that? Then you make your arc there. Now, where they intersect will be exactly 6 from there to your Z. And then if you draw with a straight line, it will be exactly 7 centimeters. It will be exactly 6 centimeters. Do not erase anything. Just leave it like that. So when we are marking, we are looking for your construction. 1, 2, 3. You get your 3 marks there for the construction. Does it make sense, guys? Easy mark. And they can only ask you to construct a triangle. Okay, Mr. Samba can just demonstrate to you over there. All right. Once you are done, they want you to measure the angle ZXY. So where X is. So you're starting from Z going to X and then to Y. So they want you to measure this angle. So you take your protractor and you're going to measure that angle. If it's correct, it must be the same. I think it was about 57 or something. Yes, sir. 57. So it must be 57. The degrees are already given. If you like, it's also fine. So we will make it anything between 56, 57, and 58, plus minus 1 degree. Eh? Not all our pencils are sharp enough. Not all of us are working accurately. So we give you an error margin over there. Yeah? So it can be plus minus 1 degree. So if you minus that and you plus it like that. Does it make sense? Yeah. Okay, perfect. So you can construct it and go and measure. You'll get the same on over there. So let's move on. If there are no questions.
So I have a question.
Okay, let me just see who I'm talking to. Tashia.
Yes, sir.
Okay, what's the question, Tashia, to the
Can
previous one?
quickly. Yes, at the construction.
Yes.
Let's say we only like left the top one, the construction thing. We just did one construction, but it still looks exactly the same. Is it still wrong?
Not technically, because what you would do now is what you guys do in that case. You put a point and then you measure exactly 8 centimeters. Now
Yes,
I want you not to do that because we want to see the construction. Therefore, I tell you, go a little bit beyond 8 so that you can put your arcs there to show that you have constructed exactly 8 centimeters. I encourage you. Although when you draw it with your exact 8, it will just look like your arc there and your arc there, and then you just do that. I don't want to see that. I want you to show your arcs there to show that you constructed that exact of 8. Is that fine?
Yes, sir.
Okay, good. All right. Any other questions here? Good stuff. Okay. Yes, Uri. Is it on the construction? After the event. Okay. So here we want to accommodate this guy's face. The guys that are not included. So it makes it a little bit flexible to do this. Otherwise, we teach there and it's going to reteach the same lesson again online. So we'll be teaching twice, where we can just do it as one. This is a very common question for you to be able to write in single log, and we know the log properties, isn't it? If you have log, say x plus your log y. This is the same as log x, y. If it was subtraction, I mean, you would say log x minus your log y would be equal to log x over y. That's basically it. And then the power law, right? If you had log x to the power of y, it is the same as your y log x. Does it make sense? Okay, this goes 3 laws. So here, what do you see? Do it one at a time. These two guys are adding, isn't it? So what does it mean? It means I can write log, and then the variables that I have here, I need to do what? Multiply them with one another. So this multiplied by that would be this, isn't it? And this okay, that's just the one. There's nothing else there. Are you following? And then you subtract, then your log x y to the power 3, which is this part here. Now that you are subtracting, we are applying this law. First, we applied that law. Are we together? So what does it mean? It means that now it will be log, and then this divide by that. So you will have your x to the power 5, y to the power 2, all by x, y to the power of that, you close that. But that you need to simplify. Are we together? So when the power, I mean the bases are the same and you divide, you will subtract the integers, right? So this one would go, which will remain, let's take a different color over here. If that one is gone, then there will be remaining 4 over here, isn't it? All of that will go, and then 2 are gone, so there'll only be 1 remaining here. So your final answer will look something like this. Your log, and then on top you would have your x to the power of 4, and at the bottom just your y. That's your final answer. So you've written it as a single log. So we give you one for the working and one for the final answer. Yes. I did. I multiplied this. No, guys. When you have x to the power of 3 multiplied by x to the power of 2, or let me rather put a to the power of that multiplied by a to the power, so that you don't confuse this with the x. What does it mean? A, you have to say this plus that, which is a to the power of 5. That's what we did. This plus that 1 is giving me 5. And then this, here. 2 plus that 1 gives me 5, and now it's just only y. You're applying integers there. Yes. Minus log x. Y. Pardon? Okay. So if you had log x to the power, guys, let's see how we restructure the question. Minus your log x y to the power 3 plus then your log x squared and then your y 2. You will do this. You'll do this first, and that answer will then add to that, which will be different. You understand? So because you know in BODMAS addition and subtraction you do from left to right. There's no priority there. So you cannot now start from the back and do that and then that. You understand? So if you apply BODMAS, you will do this part first, and then that will now give you log x that, and then x y that, and then plus then your log x squared and y squared. What's going to happen here? You now have to multiply those two, right? So they will then simplify to your x cubed and then over your y x cubed, and then you multiply that with now your, you could put it like, let's do it like this, okay? And then your x squared y squared over 1. If you want, you can simplify, right? You see that? And then you would have your log of x to the power of 5, y to the power of 2 on top, and at the bottom x, y. Does it not give you the same thing? So here this will cancel out. I'll have the 4 there, and then this will cancel out. I'll have the, what was this? Was it 1? Yeah, okay, it will be different. So just apply BODMAS left to right. Okay, very nice question. All right, guys, now, regardless of what we are doing, I want you just to stop for a moment. I know some of us are asking this question. I want you to put up your hand if you have this question correct. B. Who has B correct? Yes, there's only one person in the class that has it correct. This one here. Express in terms of that. Who has it correct? Now you know how to do it. Okay, good. So that thing applies. Yeah. No, it's fine. We can still, let's just finish the paper. Okay. You want to quickly go? What is Kari saying? Ah, no. Let's just finish the paper. Okay. All right, look at this, guys. Thank you for the time. All right, look at this. In your textbook, I can't remember the page. Mr. Kate, just confirm the page for us, please. You have this equal to log n. And then they will say that this implies that you can say m is equal to n, right? Which means that the logs are basically disappearing. You understand what I was talking about yesterday? It says that how does the log disappear? That's my boy, man. Huh? Okay, so this is a law that is stated in your book without any proof. You understand? But you can also remember, if you have something like this, look here. If you have something like, let's say, a to the power of 2x is equal to a to the power of y. This you can also just, since the bases are the same, you can just equate these two things and then you've got that equation. You remember that from that. So the basis of that is from here. So once you take the logs and you rewrite it in its exponential form, then you'll get to this. But there's an additional law that I would just like to put here on the side for those of us that like to ask questions. There's a law that we discovered last night, that is not in your book. So if you have, say, a to the power of log base a x, this is the same as x. I want you to prove this on your calculator. If you have the Casio calculator or this calculator, I want you to press the following. Put any base, 10, 9, 7, negative, whatever you want. Yeah? Let's say I put the base of 5. Then you're going to press this key on your calculator that looks like this. Log, and then you've got this where you can put the base and you have that so that we can have that function. You see that function is up there. Can you see that? But you put 5 to the power and then you put that function there. Are we together? Look, I want you to press. What is your base? What is your base? Did you all press 5? You can take a different base. Don't take 5. I have 5. Take any other base. You take 10. Perfect. Any other base. Okay, perfect. You press like that. And then you press that to the power and then you press that log thing. So it means that this base that you took here, now I took 5. Therefore, on that part, I must also put 5. If you put 10, you put 10 there. Okay? You must put, look here, press this. Look here, press your base. Look, press your base 5. Press your base 10, 8, negative, whatever. Nah? Press your base. Then you press the power key on your calculator. And then after you press the power key, you press the key that looks like this. So it looks like that. Are we together? So what I want you to do now is, I want you to put your base, the same base. If you had 10, you put 10 there. The number that you have as your base. Are we together? Are you together? All right? And then the x that you are putting here can be any number. Give me any number. The x, I put 8 now. So if I press equal to, it must give me 8. It gives you 10. 40, because you use 40 as your base. You understand? So the law says that if you have any base raised to the power of the log, and that log base is the same as this base, you put any number there, it will give you the same answer. That's a law from log altogether. So that is proven here. That's why I said use any base to get the same thing. How together? Yes. Pardon? the law is written here. If I have any base, let's take the base of B, and I raise that base to a log having the same base for the log as B, and I have any number here, and I press equal to, this will be the same number there. That's what the law states. You understand? This is what the law states. Keep that law in mind. That law will help you to get to this part. All together. Okay. So if we do that correctly, look here, guys. I don't want you to lose track of this. So you can go and look at the video again. So if we do that correctly, let's look at the following. Okay. So we have this here. Let's look at the question. So the question is an equation. I can apply the laws of log over here, isn't it? Okay, so I will have log of x to the power of 5 and y squared. Are we together? I have combined these two as a single log over there because the x cubed and the x of 2 became 5 here. Are you following? And the y square was there. And then I had the minus of that log, but I'm going to take this minus and take it to the other side. Then it will become a positive of that. Do you understand? Because I want to equate a log against a log, because I want to say, if you have the log with the same base, then I can say that the variables will be the same. So it's the logs are disappearing. Do you understand? Yeah. No, this part of writing as a single log over here and taking this to the other side to get rid of that negative that we had over here gives you this ground so that they are equal to one another. For those of us that do not want to go too deep into things, just take the law as it is. Since both logs have the same base, if you don't write, then the logs will disappear, and then you just have the equation like this, and you can make y the subject of the formula, and you get the final answer over there. That's what you can do. But if I have to show you how the logs disappear, it will take a little bit time. So you can come to us when it's break time. Any three of us, we will show you how the logs disappear by using that law there. Here the laws disappear. You will talk about it. It's good that you hope your pop spears. Yeah?
What happened to the 0?
What 0? It was still there. You just take this thing over to that side. So 0 plus that will just be that same thing.
Can you make y the subject of the formula?
Yes, you can make y the subject of the formula here. You divide by y, I mean your x5 here. You can divide here by, or you can even divide by the y square. It's rather better to divide by y square on both sides. So what's going to happen is this and this will cancel. Why I want to divide by y square is because it's going to give me only y on that side. So the 2 will go with 2 of that. So what will I have here? X to the power of 5 will be equal to x, y. Divide by x, divide by x. They cancel, right? Here it will just be 4. So y will be equal to 4x. You understand? Okay. Right. So guys, the next part is now to go into the sequences. Okay. So we've got the
Sir, can you please scroll up a bit to the last answer? I want to take a screenshot. Up again. Okay. Yes, thank you. Okay.
Welcome. Okay. Guys, we want to work through this paper now. We'll take I don't want us to take the lunch break before we're done with the paper. Let's just finish the paper. We can take a short 5-10 minute break to the loo and back, and then we come back. We'll still have our lunch break. Now, it's good to understand this. All right. So since they're saying this is GP, we know the general form for the GP. What is the general form for the GP? That you can find any term equal to AR to the power n minus 1. That's the general form we have, isn't it? So yes. So did you get the formula? Not more for the substitution, man. The formula not. Okay. So from here, what we're going to give you is that we are talking about the 10th and the 80th term. Are we together? So they are telling us that now you need to write down not the 10th, but the third term is equal to 10. And then the 10th term is equal to 80. This is important. No? Pardon? Sixth term. Sorry. I'm seeing the 10 there. Thank you very much. So the sixth term is equal to 80. This is very important that we put this because this is going to help us now to put the two equations together, right? So what do? You take that and then you start substituting now. So if we substitute, what will we have? What is n, by the way? Number of terms. So what will happen if we do this for this one? It will reduce to AR squared is equal to 10. Are you agreeing with that?
Yeah.
For this one, AR is equal to 10. You remember, any number of terms is equal to this thing. You get what I'm saying? Are we following? So now we have that thing over here. This and the R are there. Now I want to know, how do I get, because the term that we're talking about, the third term will be equal to 10. So I could put even like this, 10 is equal to AR2. It doesn't matter. You get what I'm saying? Now the question is, how do we get the 2? 3 minus 1, because you're talking about the third term. You understand? The n here is the 3. 3 minus 1 gives you your 2. Does that make sense? Exactly. That's what we do. You understand? So for this one, the third term is equal to 10. So this one will now be what? The term that you're looking for, the third term equal to that, will now imply that you have that. Now I like to write it like this. Squared, and then that will be equal to 10. Are we following? And then you do the same thing. Your sixth term will be equal to 80. So this will reduce to what? What will this be? 5. Perfect. Equal to 80. How did I get the 5? I said now 6 minus 1 gave me the 5. Are we together? So now, technically, you are solving these two equations simultaneously. Are we together? So these two that are on the side, you will now say, what do you put now? You put the big one over the small one. So you would take now your AR5, it's supposed to be 5, over your AR squared will be equal to your 80 over your 10. That's how you put your ratio. Are we together? So the A and the A will cancel, and then this R and R will become R to the power of 3, because the bases are the same. This will be minus, the 2 will cancel, we've got 3 over there, and all of that will be equal to 8. And then you cube root both sides, isn't it? Because you want to get rid of that cube. So if you cube root both sides, this and this cancels, your R will just be equal to 2. Are we together? So you solve for R. Your R here will just be 2. Are we together? Huh? And the reason why we sometimes struggle with this, guys, is because of the algebra that is involved in it. Mr. K, what is the reason why we have to say the big one over the small one? The ratio that we're getting there. Yeah? No, the ratio of, pardon? This part here, when we are solving for our R over here, why are we saying the big one divided by the small one, the ratio that we're getting there? I think everybody understands this point, that we are looking for the third term in that progression that is equal to 10. And then we are also looking for the sixth term in that progression that is equal to 80. So if that progression is having whatever terms they are having, the third term, maybe the first term is here, the second term, the third term will be equal to 10. That's what it says, right? And if you go on, the sixth term will be equal to 80. Yes.
Actually, it's always the current divided by the previous one.
Perfect.
So when you say it's Tn divided by Tn minus 1.
Yes. So what it means is that if the progression is going from here up to here, so you will say your Tn is here, divide by the Tn minus your 1. So it will be this current minus that. It's nothing to do with the big value minus the small value. Even if it had a smaller value, this was decreasing. It will always be that, so that we don't confuse that.
So basically, that's why we say 3 divided by 3 2 equals what? 3 2 divided by
Exactly. 2, 3.
That is 3.
Are we together? Okay. So let's just get that clear, because some of us will tell you big one minus, and then in another sequence you get a small one, and then you might confuse them. There, please understand that. Yes.
Sir, so the ratio is 2.
The R is 2. Yes. The ratio is 2. That's correct. So whenever you are doing it like this, the ratio there will be 2. So it will always be the current term divided by the previous one. You understand? Or the last one divided by that. That is what we are trying to stretch out over here. This one over there. So now look here. I'm going to explain this again. Please follow. Please follow. Okay? So we established from the statement that the third term in that progression is equal to 10. The sixth term is equal to 80. And this is what we established from that statement. Now we are using these two terms to find the common ratio, which is R. Why common ratio? Because we are dealing with a GP. If it was the AP, it will be the common difference. Are we following? How do we find the ratio? We are coming from the general formula. What was the general formula? For any term, you take your A. What does A represent? Yes, your first term, and then your N minus your 1. The N is the number of terms. Which term are we talking about? Are we together? So we are just taking this thing here. So if you rewrite it like that, it's almost like saying that since this is equal to 10, that Tn is equal to 10 now. That is why we are equating it to 10. You understand? It's not just a general thing anymore. It's not a Tn, it's a specific value. Are we together? So in other words, I can now say that 10 will be equal to the general form. Are we together? Which will be your first term, your ratio, and which term are we talking about? We're talking about the third term minus the 1. So this is where your N was. So that will now reduce to AR squared is equal to 10. And this is what we're looking for. So that this will help us to find the ratio. We do the same thing here. The sixth term is having a number of, the value of 80. So the sixth term here is 80. So therefore we will say, which term are we talking about? The sixth term minus that by 1 because of the general formula here will be equal to 80. Does that make sense? And then if we simplify this, this will now give us, let me just get this clear over here so I have a bit of space. If we simplify this, then this will now give us what? AR to the power of 5 is equal to 80. We are looking for this 2 so that we use this 2 to find the ratio. Are we together? Now, since the 10th term, not the 10th, but the third term is preceding the sixth term, we need to put the bigger one over the last one over the previous one or whatsoever. You understand? It doesn't have to be the previous one because we are between 3 and 6. There's still the fourth and the fifth term in between. You understand? So therefore, we're going to take these 2 and then we're going to divide them with one another. So what are we going to do? We take the last one. Are we together? Equal to 80 over the previous one or the preceding one. Or I don't know. Yeah, not one. Not the small one. It's like, in a sequence you have the terms like this, right? So here we are talking about the third term and we're talking about the sixth term. So you take the last one and the previous one, or the previous just sounds like it's the one just next to it. So the one somewhere before it. Yeah? So we have that over this, and then this will now be over that. Are you following that? So the A and the A will cancel. So this is just normal interest you are applying. That's how we came to this, because this divided by this, will be 8. So cube root on both sides. Cube root here was resulting for R to be 2. Do you understand? So the R is 2 over there. That's what we established here for this question. Your R is 2. Does it make sense? Yes.
So what does it mean as a B?
Pardon? No. This is the second big question. We are not there yet. No, let's just finish this question, then we can call a short break. What is after this? That is the problem I'm having, guys. Those guys that got the 60s and the 70s, 80s are the ones that don't complain. So those ones that got what we got are the ones that have to complain. Yeah, guys, the mind has to be fit. Yeah, and my young word clique has a tendency of doing things that they are asked not to do. Yeah, so they were asked not to go to the shop because it's just a 30-minute break. It takes you an hour to walk to the shop if you go all the way around, but then we would still opt to do that. So guys, please, nah? No, it's not a lot, man. We're just going to finish this question. That's it. Now we have to find the first term. How do we find the first term? Remember, we have the A, R, are we together? Must be equal to what? What is the general thing that you have there? And we are talking about the first term. You understand? So you just plug in your R here. Which term are we talking about? The first term. Are we together? So when you plug in your R, you would be having what? What will you be having? A, R, up here, you'll have your 2 there, to the power of 2. And then you will have that equal to, no, the first term is the 10th term. Sorry guys, sorry. Now I'm messing it up. No. Sorry for the English. Let's get that clear. What I have over here is to say the following. Because what are we talking about? We're talking about in that sequence, right? So if we have that in that sequence, we will have our, maybe I should write it here. We have our A, the 2 is our R, to the power of 2 must be equal to 10. What you are using is any of those 2 previous equations you had. Remember, you had the one for the third term and the one for the first term. The sixth term. So since we are using the one with the one for the third term, remember, we had something like this. A squared was equal to 10. Then we had the AR to the power of 5 was equal to 80. So you could use this one or you could use that one. So we are using this relationship since we calculated R for both of them. Remember, the common ratio will be the same, right? So you could use this or what? So the R we have, that's why I use that one. So that's the 2 that I have for the R. Are we together? So if I substitute that 2 squared will now just be 4A is equal to 10. You divide by 4, you divide by 4, this will cancel. Your first term A will be equal to 2.5. Are we together? That is what we'll have. If we do that here, we'll also have the same answer. You understand? It doesn't matter which one you are using. And then the sum. Yeah, it's a long formula. No? I don't know how you can memorize that formula. Maybe you have to put it and you reside it. The more you do it. So the formula we have will be the sum will be equal to A, and then you have your R to the power of N minus your 1. And then down here you will have just your R that. Substitute everything you have. The R is there, the A is there, and then you are talking about which term? The 7th term. So basically the sum up to the 7th term. So the N just becomes 7. The A you've calculated to be 2.5. The R is 2. Your R is 2. So if you substitute correctly, you would say the sum of the first the 7th term, the first 7th term will now be the 2.5, and then this your R was what? 2.2 then. That's 2. Sorry, 2 to the power of 7 minus 1 all over now your 2 minus 1. When I did that, first here I got 635 over 2. And then if I simplify that, it was giving me something like this, 3 significant figures, it was giving me that. So I think we were accepting both. Yes. You didn't get the mark for the first term. The first term. So for you to find the first term, remember you got your R by using these 2 things, right? So from these 2 things that you're using, we just come and substitute the R. Let's say we use this one. We have the 8. So your R is what? Your R is 2, all raised to the power of 5. And then this one is what? 80. So when you solve this, 2 to the power of 5 is what? I think it's 32 or what? Quickly confirm. 2 to the power of 5? 32. It's 32 now. 32A equal to 80. So you divide by 32, you divide by 32. It should give you 2.5. You understand? So you are using the two equations that you started with to find your R. I mean, to find your A after you found your R. Any of the two. Look, we use this one here, the second one now. We get the same answer. In the first example, we use the first one, we got the same answer. So it doesn't matter which one you use. So the two will help you to find your R. Once you find your R, you use any of the two to find your A. Does it make sense? Okay. It doesn't have to be one specific one. Okay, so we can stop here. I think this algebra things, guys, really, it's things that we can skip. Even this one's here, Is the algebra fine? Can we skip the algebra? The algebra, ne? Yeah, because even the angle, most of you see here, because it's out of 180, I think this must give me 54, isn't it? Because I've got that. These are alternate angles. I've got two parallel lines. Do you see the Z? If I don't see them as the alternate angles, I can see them as the co-interior. That plus that must add up to 180. So I'll say 180 minus this 78 plus then the 48. Because that and that must give me that. It will also give you the same answer as that. You can use the co-interior or the alternating angle property. And this one you'll get by saying what? That minus the 180 must give you 126, isn't it? Because they make a whole 180. I think most of you did very well in this question. This one was not a problem, so we found X and we found Y. So the X is from the straight line, the Y is from the co-interior or alternating angles, and then let us just quickly do while we are here. Listen, this is where most of us are struggling. We do not see the -1 there. Yes. You understand? Because that is what you have to multiply in. 2y minus y plus 7 is equal to 15. Are we following? Taking the 7 over to that side will give you what? 15 minus 7. Okay, and this side 2y minus that will just be y, isn't it? And then this will equal to what? 8. So your y is just equal to 8. You see, it's very simple. Nah? See the one there. And then this one, of course, guys, you know how to do your brackets, isn't it? If you don't know, go and do the formula there. Yeah, the formula of completing the square, whichever works for you. So I think this question has a lot of ways to explain those brackets. But if you do it correctly, we've got the y to be that, and the y plus 5, and then you equate that to 0, isn't it? So the first bracket will be equal to 0. The reason why you equate it to 0 is you want to solve for the y. So anything multiplied by 0 will just be 0. Né? So you will have for one of them y is minus 3 is 0, or y plus 5 is equal to 0. And then you will say y is equal to positive 3, y is equal to negative 5. 3 and negative 5. That one is fine. Are we together? So that one can be very, 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 very straightforward. Okay, so giving your answer to 2 decimal places, again, guys, try to get rid of fractions. So take this as if it's 1/1 and try to combine this as one fraction. And then you can do your cross multiplication. And then after that, you can then get the linear equation for you to solve your y. Are we together? So if you do this, it's like you have to multiply this with x minus 3, multiply with x minus 3. So you'll have your x minus 3 on top, right? Minus your 7. And then at the bottom, you would now have your x minus your 3, all of that equal to that. And then I think the quadratic equation you're supposed to get there must be this. We are having this plus the 9 equal to 0. You solve your 2x's there. I think this one you have to use the formula, né? Because there were decimals. Here we've got 0.73 and your 12.27. you use the formula. Identify your A is 1, your B is equal to minus 13, your C is equal to 9. You know the formula, right? Whatever x you are looking for will be minus B plus minus the square root of B squared minus your 4AC, everything over 2A. Substitute your A, B, C there, and then you can find the answer. All together. Is that clear? Yes. Okay, the 2, 1, 2, and then maybe to get to this point, 2 points for 2 marks for the method. Okay. So you see, we are done with that. So we are done with most part. I think we can come and sketch after the break. Or you want us to sketch the graph now? Let's quickly sketch, guys. Okay, let's sketch after break. It's 12 minutes past 1. So guys online, we'll continue 1:30, 15-minute break there. Please don't go anywhere. Just here, if you have the bread, you eat your bread, or go and drink water if you don't have bread. So just don't go anywhere. We'll still get the lunch break. So
Sir.
Yes. Yes, Saya.
Sir, can you please go back to the geometric sequence? Like,
Okay.
I want to copy the answer.
Can I rewrite it for you more neatly or? Saya?
I think I can.
Ask a question on your paper. We are here. Saya, do you want me to rewrite this neatly or will you understand what's going on here?
Sir, can you please rewrite it neatly?
Okay, let me just get, I don't know where I placed my pen. I put my pen somewhere.
Okay.
Okay, just give me a second. Guys, Mr.
Okay.
Katam, we are all still here. Those of you that are not going on break, go with your question paper. You can ask your questions. Né? Okay. Those online, I'm also here. You can still ask questions. Please, guys, don't go off from the premises. Please, please. Yes. I think after this it will go a little bit faster, maybe by 2 o'clock. If you come back 1:30, maybe 30 minutes, 45 minutes, we're done. 2:45. Guys, what do you have to go and do it for? You just study math. Where are you going? It's you cannot. Not now, not now, not now. You will have a long break. You'll have a 1 hour break. This is just a 15-minute break. Go to the bathroom and so, not now. Guys, you all ate breakfast this morning. I just drank a cup of coffee. You must start fasting for your exam. So I want my mark. You want your mark? I'll give you your mark now. Go down. JJ, there's Zula marks. Okay, Saya, are you still there? Saya?
Yes, sir. Yes, sir, I'm still here.
Yeah, this thing is just taking longer than.
Okay.
Yeah. Okay. So is it the whole question or just a part of the question? We'll give you after we're done with it. The whole question.
Just question C. Just question C.
Oh, you only want question C.
Yes.
Are the rest fine?
Yes, the rest are fine.
Okay. So on question C, Saya, we need to follow the formula. Oh, what did I do now? Oh, sorry. Okay. Okay. So, Saya, here you need to know your formula, nah? Saya, are you following?
Yes, sir.
So you need to know the general formula that says the sum, especially for the GP that we're dealing with here, will now be your A multiplied by your R to the power of 1. I mean, to the power of n minus that over now your R minus 1. That's the general formula. A being the first term, okay? You know that, right? So this A is your first term, and your n is the specific number of that term. Okay, so here they are saying you should get the first 7 term. So the sum means if the first term was this, the second term was this, and it goes up, it's like 1 plus 2 plus 3 plus 4 plus, you understand? That's what it means. But now with this formula, you can do it in one go. So this is what it is generally, but we're looking for the sum of what? The 7 terms. So the first 7 terms. So the first term we calculated it to be 2.5 in the previous question, and then your R was 2, the ratio, right? And then this will now also be 7. You see what I'm doing here? The ends I'm replacing like that. Okay? And then minus your 1 all over now your R is 2, right? Minus 1. If you press this in the calculator, I think I was getting an answer. This was giving me 635 over 2. And then if I do that, I was getting 317.5, which is almost 318 if I take it to 3 significant figures. Does it make sense?
Yes, sir.
Okay, good. Is that only question? Is there anyone else that have a question? Those online, are you guys fine? Natangwa, you should start coming to class, man.
Yes, sir.
So we can do linear programming with you.
Yes, sir. From next week.
Yeah. If we meet tomorrow, you should come. Okay.
Tomorrow.
So guys, we have. If you have questions, I'll keep it on. It's supposed to be a break now for the next 10 minutes or so. But we are around, we'll always hear you when you want to. I think we'll ask Mr. Summer to share the paper. I'll be with you. Okay. So, you understand that after you plot, we say write down the coordinates for what? For this graph. Remember that y is the same as that. So this is the graph of the total. So the training coordinate you put the coordinates. Now they say graphically find the solution where that graph is equal to 0. So what it means is now this one is the same as that. 1 is 1. This line now is equal to 0. Where is the y-axis? So where the y-axis started 0, you understand? You want to find the solution. If they maybe say, take that then we say the y-axis even if we say take that graph, then you say which axis is that? The y is that and it's 2. Now they're saying that graph is equal to this graph. This graph is y is equal to so that graph is equal to
Sir,
yes, I'm listening.
can you please re-explain number 7B?
Okay, number 7B.
Yes.
Okay, I'll be with you now.
Okay.
Okay, you're welcome. All right, you said question 7. Was re-explain question 7.
Yes, number 7B.
Number 7B. Okay, let's quickly see where it is. Oh, sorry, the zooming is too much. Okay, number 7B. Okay, maybe should I explain as to the whole thing why we drop the logs or just the simple way of? Which one do you want me to look at?
I think the whole thing.
The
Or
whole
maybe
thing.
we can just answer the question.
Okay. All right, let's first answer the question, and then as the lady on the side also just explains to you why. Do you have that y equals mx plus c textbook?
No, I have the other one.
Solid
Another
foundation.
one.
The one are the using. Sorry, guys, this is now rolling out. Which other one are you guys using that side?
I have the textbook, the part 1 and part 2 together. It's like a big math textbook, but it's the new curriculum.
Does it have a title? Who is it, platinum or what is it called?
Let me check.
Then what you got?
Namco. It's a Namco math textbook.
Okay. Oh yeah, I see those ones. Okay. Now look at the question here. What they are asking us, try to get the pen. Okay, is for us to write y in terms of x if you have this whole log thing. Now what I want you to notice here is that this is an equation because of the equal sign here. So what I'm going to do now is, in that one textbook, I think the y equals mx plus c textbook, they have this thing here, that log base 10. You know that log base 10 we don't write here. If we just write only log, it just means it already automatically has base 10. That's one way we show it. So if that was, say, for example, x equal to log y, then they say that this is the same as just saying x is equal to 1. Now, some people will say you just divide both sides by log. Technically, that's not right. That's why I'm saying there's another way of showing how this comes there. So if you know this property, the idea is to find a log on one side equal to a log on the other side. That's the idea. So we are using this concept for us to solve this. Therefore, I was thinking of taking this whole one to the other side. So if we take it to the other side, it becomes a positive, right? So it will just be log x y to the power of 3. Because this negative will go and change, right? And then this 2 here, we're going to write it as a single log because I've got a single log over here equal to another single log over here. Does that make sense? So if we add them together, we have to multiply the variables there. So since these bases are the same, then we would have log So we'll have x 3 and 2. When we add them, we have 5. And then we'll only have the y 2. So now it's the same thing as this. I've got a log with the same base equal to one another. So now I can drop the logs. Then I can have something like this. All together. Is that making sense? Based on this property here. And then, because the question was asking me to write in terms of x, I need to make y the subject of the formula in terms of x. So I've got y on both sides. So the reason why I said I would rather divide this side with y squared and divide this side with y squared was because this and this can cancel out. And then this will cancel out with that. So which means I already have y on its own. So that means that I will have x to the power of 5 equal to, on this side, what will I have now? Equal to xy. You understand? Because these two have canceled with two of them, there's only one left. So I'm going to take this and write it in terms of y only. So divide by x, divide by x. This and this are out. This is out with one of them, it's 4 left. So technically, it's like 4x is equal to y. But since we read from left to right, I can just say y is equal to 4 to the power of, x to the power of 4, not 4x, x to the power of 4. So your final answer, you see, they expect you to put it like that. So you will just have x to the power of 4. That is your final answer. Does it make sense?
Yes.
Okay. Good.
So can you please scroll up? Let me copy.
Can I do what?
Scroll up. Let me copy the answer.
Okay, let me just do this. Again, I just do it.
Yeah.
Is that okay?
Yes. Yes.
Okay, good. Can you tell those guys to come back? We're almost back again. Okay, my online people, any other question, or we'll just wait to continue with the sketching? Okay, come on, you guys, let's start. Just wait. Just wait. But the thing is nice. Okay, guys, let's settle down. Let's continue. We want to go on break by 1 o'clock, 1:15, yeah? So, yeah, since 1:15 until 3:15. Guys, after that 1 hour break, listen, after that 1 hour break for the paper 1, where it's really numbers, I want at least another hour and a half to 2 hours. That's when I'm going quick, Ms. Mugunda up. You are now nicely having something in the tummy. We have now revived. So let us just say we take the break, say 1:15. Yeah? I'll just watch the time and just move a little bit fast. And then from 1:15, yeah? 1:15 until 2:15. When we come back there, is it already 2:15?
It's now 1:30.
Oh, 1:30. I thought it's 1:12. So 2:15 until 3:15. Then when we come back, then we can push to 5. Then an hour and 45 minutes. Then we go home. Yeah, because you're taking the break, guys. Come, really, hour. Okay, so we are back from our break. We could go and drink some water, and I did not even drink water, and I feel so thirsty. Okay, we'll drink later. If you rest, you rust. Yeah? Okay, I think completing the square. Mr. K, how was this question? You're fine with completing the square. How was it? Like, was it not just the sketching? The completing square was also a problem. Okay, listen. Let's quickly look at completing of the square. We have seen the point whereby we could complete this nicely by, I know that thing that we draw for you, but we don't have the time to do it now. So what I want you to notice is that the general form of any quadratic equation looks something like this, isn't it? So when you complete the square, you take the b term and then you divide that by 2. You follow it? And you square that. That term you add and subtract to the same expression or equation. So that, as if when you add and subtract something, it's like you're doing nothing. I give you a $10 and take it back, you have nothing. You understand what I'm saying? But the time that you have the $10, you can quickly go and do your things and I only come after 2 hours and make sure I have it back after 2 hours. You understand? But it's not really yours. So that's what we mean with it. So if we look at this, our b here is -6, isn't it? So this will now be -6 divided by 2. That has to be squared, right? And that term has to be added and subtracted to that quadratic equation. So if we do that, the quadratic equation has got your x squared. And before we complete the square, ensure that the coefficient in front of your quadratic one, the x squared is 1. In our case, we are lucky, it's already 1. If there was a 5, you would have divided by 5 throughout. So that becomes 1. Are we following? Okay, so we have that minus then your 6x, all right? Then you can add that term over here, and then you've got now your +8, and then you can subtract that term over there. Now, do you understand? Yes. It doesn't matter whether you add or subtract, whichever way. What will determine that thing that comes in the middle will be the sign of that. Are we together? So even if you now say you subtracted here and then you went to go and add there, it doesn't matter. What will determine that middle term is the sign of that b that you have there. Are we together? So like I give you the $10 and I take it away as if I've done nothing. You understand? So that term that we add and subtract there will now be the term here as your b was now your -6 over your 2. All of that was squared. -6 over the 2. All of that was squared. Are you following, guys? You could opt to simplify it. It's up to you. You could have squared the 36 over 4. It's up to you. So what happens in this case is now, when you have this square and this square, I want to show you that take it as if it's a sandwich, né? As if the middle term disappears. Are we together? So what I mean with that is the following. You get a square, I mean a bracket with a square. Are you following? So the middle term falls away. You'll have the first term x, and then you will have this term here. Your that's what I said. The sign is dependent on what you are having here. Are we together? So then you will have your 6 over your 2. The square is as if you are factoring it out. For lack of better words, or better explanation, yeah? It's like you are taking out only the ones in the square. This falls away. And then, of course, this guy has a negative there, right? And then this 8 plus your 8. And then what? This is a number, isn't it? Are you seeing that? So you could simplify that. This will give you most probably minus your 36. Because 6 squared or negative 6 squared would be that over 4. That's a number, right? Which is what? 9, isn't it? 36 divided by 4 should give you 9, isn't it? All right. So this whole number, you could rewrite it as your x minus your 6 over your 2. And then your this plus then your 8 plus then your, minus your 9. As a matter of fact, we can even already simplify. Because this value that you have, 6 over 2 is what? This one here. 6 over 2 is just 3, isn't it? So you will just have it as x minus 3, everything squared, 8 minus 9, which is giving you -1. Are we together? So there you completed the square. So that is what we want to see. So that addition and subtraction, it can give you 1 mark. This thing that you show me that it falls away is another mark, and the third mark is for the answer. Yes. No, because if you square any negative number, it becomes positive. -6 times -6 is a positive 6. You square them now. -6 over 2 is the square. Square this, square this. So it's like -6 times -6 over 2 times 2. Will give you just 36 over 4, isn't it? And remember, the other negative I had was part of the equation. It was part of this equation, that negative. But the answer became positive. Why does it go away? Very good question. Again, this goes to the proving that x minus 3 squared is the same as x minus 3, x minus 3, isn't it? The bracket has to be multiplied by itself twice. Expand this, and you'll get back to that answer. That's how you prove it. You understand? So that you don't just take it as it just disappears. You get what I'm saying? So if you expand this, this will give you x squared, and this will give you plus 3x, right? And then you will give you, was it minus, eh? Pardon? Minus what? No. I was just talking about only this part. But if you expand it, you will get back to that. Plus, then you have your 8 and you know the -1 that you are having there. So -1. So all you need to know is once I come to the point of squares, this will fall away. If you want to go and prove it, you can go and prove it later. You understand? That's the proof behind it. So now we've got that answer over there. Yes, G?
So I don't understand the -1.
Because it was 8 minus 9. Why do you plus it? Because this was minus, isn't it? Because you added this term and you subtracted that term. So this term, you remember it's in brackets. So that you have to treat it on its own. Then the subtraction is already, you understand what I'm saying? Okay. So with that said, so now we've got that part. Now, guys, I want to, and I like this question because there was a time that I was actually wanting to explain this to you, why you need to do completing of the square. Why is it important for you to do completing of the square? Because the application of completing of the square is for you to find the turning point of your quadratic equation. Are you following that? So when we are finding the quadratic, sorry, I was trying to call you when I was on break. Now I'm back in class. Just SMS me, please. Okay. All right. Thank you. So what I was trying to say here is that remember They are telling us that rewrite it in the form of x plus your p, okay, plus then your q. Where does this come from? This comes from this point here. You see that? You can rewrite it in that form. Sometimes when you have a coefficient in front of your x, like they are saying your ax squared plus your bx plus your c. If you complete the square, it comes to that point. Some textbooks are using a and b there, I mean b and c, but the p and q are the correct ones. Are we following? So what this form helps you to do is that these values that you have here, your p and q is where your turning point is. Are you following? So your turning point is having the following formula: minus or negative p and your q. This here is the general form of your turning point. Of course, we can also get the turning point from that middle term of b over 2a, what. That is more AS level, but this is how you can find the turning point. Please take this as your general formula for you to find your turning point. Are we together? So what it means is that once you have written this in the form of completing a square, like the way we had it was x minus 3 squared minus 1. What is your p here? Your p here is equal to negative 3. Your q here is equal to negative 1. That's what the general form of this means. You see that? Are we okay with this, guys? So if you take your p and your q and you go and substitute into the general form here, it's as if you are saying that minus that was already part of it with this negative 3, and then the coordinate of that would just be q as it is. So which means your turning point would be negative with negative will now be equal to your positive 3, and that will be your negative 1. So this is the coordinate for your turning point. Does it make sense? Are we together? So that negative p and q is a general form. So once you have put it into the quadratic formula, completed the square and have it in that form, you get your p and your q from there, substitute it in the minus p and the q so that you can get that. So what this minus is just telling you is whatever you find for your p, change the sign. Does it make sense? Okay, so this is the coordinate for the first turning point, which is most probably going to be x would be 3 and your y would be negative. So maybe your x is 3 here and y is negative 3. So somewhere here is the turning point. Are we together? So your graph could come and turn like this, or your graph could also turn like this. Now the positive turn or the sad face negative turn or the positive term is determined by what is the sign of your x squared. Your x squared is positive, right? Which means your graph will be a smiley face. Therefore, your graph would look something like this. So we already have an idea that this is the turning point at the coordinate of 3 and negative 1. We have that. Are we together? Then we need to see where is the graph cutting the x-axis. Then you have to solve your two values for x from there. Are we together? You could take the general quadratic and go and do the your formula, or you could just solve it from this what is this completing of the square. So then you will get the exact values for your x, and then to find where the graph cuts the y-axis, you now need to take that formula, equate that y, wherever there's x, you put 0. Then you'll find your y. So that is in a nutshell. Now let me explain. Let me do that now in more specifics now by elaborating a little bit how to sketch the graph. Are we together, guys? Okay, so let us first start with the completing of the square. The what is this thing called? The formula that we have for completing of the square, which will help us to find the turning point. Once we find the turning point, we get the two values for where the graph cuts the x-axis. After we get those two values for the x-axis, then we'll get where the graph cuts the y-axis. Are we together, guys? Okay, so please listen very carefully. To some of you, this might be the first time that you're seeing it. Some of you, your teachers might have covered it. So I don't know, maybe we take that color. I don't know whether it will work. So we start from the fact that x3 squared minus 1. That is the completing of square we got from the other one. Please take your paper and you write. Don't look at me just like that, guys. Because when you get home, only take your paper out and you write. Because if you get home, where is your paper? No, just sit with your paper. Why is he having your paper?
No, sir, I know it's correct.
No. He doesn't have everything correct. Let's put it together so that you can understand, please. All right. So now, from this table, we know the general form of this. This is where my P is, and this is where my Q is. So that already tells me that my P is equal to -3. Okay? And my Q is equal to -1. Are we together? We take that now to the general form of the turning point. And the general form of the turning point is change the sign of your P. Are we together? So therefore, your turning point now will now be, your P was 3, -3, so it will now become 3. It's like the negative times the negative will become positive. This one you just take as it is. So what did we do? We found the turning point. So that already is part of the sketching of the graph. So we have this part. That is fine. We're looking for that. Now we're going to find your X, where the graph cuts the X. So are we together here? I hope you understand that this is new information. Who is seeing this for the first time? Yes, this is new information to most of you. Okay? Yes. That's what I'm saying. The general formula for this is -P. So you are bringing in already with the general formula, you're bringing in the -3 as it was, and the negative and negative becomes positive. Just know that the sign of the P always change to make it easy for you. Nah? Okay. There's a whole method of how to derive that. We don't need to go through that. Okay. Now on this side over here, what I will now do is with a darker color is to find where we cut the x-axis. Are we together? So please understand that this formula that we are having here, x minus your 3 squared minus 1, I equate to 0. Are we together? When I equate that to 0, I can solve for x now, isn't it? So what happens here? I can do the following. I can take this over there. It becomes a positive 1. And this will now be x3 and then square here. Are we together? So what do I do now? I could square root here. I also square root here, isn't it? So when I square root here, this and this will cancel. Are you following? So this will now be x minus 3 will be equal to plus minus 1. So the plus minus is giving me the two different x's. Are you following that? If I do it from this formula, I could have done it another way again. So we would then take the first one. So the first one would now be x minus 3 equal to a positive 1. Are we together? Or x minus 3 equal to a negative 1. Okay? Make x a subject of the formula. X will now be equal to 1 plus 3. So the 3 is going over. So therefore my x will be equal to 4. And in this case, I do the same thing. I take the 3 over to that side. So it will be x is equal to negative 1 plus 3. So which means my x will be equal to what? 2, isn't it? Because it will be negative 1 over 3. So x can be this or that. So it tells me that on the x-axis, I'm going to cut at 2 and I'm going to cut at 4. Are we together? Yes, sir. So if your graph, because your x here was positive, man, look at this for your graph. This x was positive, therefore your graph will go like that. If that x squared is negative, then your graph will go like that. So what do we have so far? On that, we know that the graph will cut the 2 and the 4 on the x-axis. The turning point will be at 3 and negative 1. We have that now. Now we just want to see where will it cut the y-axis. You understand? Okay. So at the y-axis, you can have this over here. You can make, remember, this is the same as y is equal to x squared minus 6x plus 8, isn't it? Make x 0, and that's how you will find your y be 8. You understand? You have to go back to that one. I'll just explain on the same drawing here. So we have some consistency here. Okay. So we want y. We can't use this because there's no y variable in here. You understand? Therefore, we go back to the original one. Now, the original one states that it's x squared plus, can you give me that? I can't remember. Okay, so it will be minus 6x plus 8. Okay, so what will happen is this is the same as y is equal to that, right? Or f of x. So wherever there is x now, I'm going to put a 0. So what's going to happen is I'll say y will be equal to 0 squared minus 6, 0 plus 8. This will go to 0, this will go to 0, so y will be equal to 8. So it means that if I sketch that graph, it will cut the y-axis at 8. Are we together? Yes. So let's do this. So I want you also now just to sort of like use a little bit of common sense, guys. Try to have a little bit of intervals that are more or less the same. Let's say if this is 1, maybe this is 2, this is 3, and this is 4, this is 5. Sometimes you can have big numbers like 50 or because it's just a rough sketch. But we have small numbers here. Are we together? And then you could say that this is say your 1, maybe this is your -2, this is your -3, and it goes like that. And you could say 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have everything within, right? So where is my turning point? So I can now say which color can we use so that we have it nice? Blue.
Blue.
Let's accommodate the blue. Okay, so we are told that on the x-axis, and this is the y-axis, right? So here is where I have my 2, and here is where I have my 4. Are you following that? And then I have my 3 over here with my -1 over here. So my turning point, this is my turning point will be equal to what? 3 and -1. Are you following? And the y-axis will be cut now on 8. So I'll go 1, 2, 3, 4, 5, 6, 7, somewhere there. Are we together? So I need to include all of those things over there. Are you following that? So what's going to happen here? I'll have to come from here. Now this is where the sketching becomes very difficult on a board. Okay, because it takes my other hand. Okay, let's try again. So you come down through the 2, turn at that turning point, and you go up again. So then you please write 8, 2, 4, and you put your turning point. So this is what the graph needs to look like. So where are we giving the 4 marks or 5 marks? How many marks is it? Right. So the turning point, this 2, and then where it comes and turns. Okay, no problem. And then the shape of your graph. Is it the right way? Those are your 5 marks. So this mark here is for the shape. Okay, are you following, guys? So that is what your sketch must look like. Don't try your paper. Are we following, guys? Is that fine? Are we having questions here? Online people, are you fine?
Yes, sir.
Yes, sir.
Good. This is the application of that. You understand? So if you have to go and build a dam hole where they put the what is this floodgate or whatsoever, and you've got this parabolic shape because it's good for the pressure, you have to do the calculations. Where is your turning point? How are you going to put the gates? You go into civil engineering, you'll do this basics. Of course, there are programs that can do those calculations, but the program has to be instructed by someone that has the knowledge. Are you following? So this is what it looks like. It's quite an interesting question. I think your next paper might maybe ask you to sketch now, yeah? Like not the sketch roughly like this, you know, with the table method and what. You saw in this paper, we did not have that. Are we together? But this was then accommodated by this. It's quite it's not a straightforward question. I know most of us will not do well in this question before this explanation. Yes.
So what I realized is that if you substitute, for example, like 1 or 2, it will end up being something like this.
If you substitute, you mean you take this part here?
No, it's,
Or you mean in the initial one here? Here. Here.
it ends up being this.
Oh, yeah. You see what what JJ did, which is actually very interesting, né? He just put his table there. So you know you get now your x and your y. So you start with the 0, 0, for example. Or let's not say the y would be 0, we don't know. So you take a bunch of values here to the negative, and then you take a bunch of values to the positive. So do you see how powerful that is? It gave you the same shape. Yeah, you understand? We just didn't know exactly where's the turning point. So now the turning point you can calculate. So when the going gets tough, you can put your table down. Are we together? All right, so this is something like this. So this is fine. I think that will be okay. If there are no questions, I think this question is fine. We can really do justice to this. Now, they're telling us we've got the cone there. The slanted height is given as that. And then if you take the perpendicular height here, which is perpendicular to that, maybe we call that h. We can calculate h by using Pythagoras, isn't it? We can find the height of it. So one could say the height of that will now be the long side, which is your hypotenuse, minus the other given side that you have over there. This will now be 36 minus your 9. The square root of that, I think it should be 27, isn't it? Square root of 27. I don't know, what did you get? 5.1. I don't know what I put in my mind. Let's just confirm. I should have done it somewhere. Okay, give it to 3 significant figures. 5.1. No, 3 significant figures. 5.1 is 5.20. That's the 3 significant figures. Okay, so that one is fine. I don't know, I might have done it somewhere here. So that part is okay, yeah? All right, so after you have that, they want us now to find the total surface area. Guys, I think this question was very clear. You just substitute. There's nothing else you can do. The slanted height L, because that's what they tell you. But some of us, because they ask us to calculate here, want to go and substitute H. The slanted height here is this one here, which is 6, and that is your L. So what do? You would now come and say, okay, the total surface area of that cone will be equal to your pi multiplied by your radius was 3 multiplied by your slanted height of 6. So that's the first part, plus then your pi multiplied by your radius of 3 being squared, which is anyway just 9. So this is giving me 18, isn't it? Times pi plus then the 9 pi. That is giving me 27, right? Isn't it? So this will give me 27 pi. 18 pi plus 27 pi. So your answer could be 27 pi, or if you write it out in words, not words, not English, right? So the 3 significant figures could be that. How did I get this from here to there? I just say this multiplied by pi. Yes. Is it not the total surface area? Okay, wait. The surface area of the curved part of the cone. Then they give us the total surface area. Okay, so where is the curved part, guys? So which means you need to get the circle and subtract it from here, because that's at the bottom part, which is you understand? So this is what the cone looks like. Perfect. Thank you for identifying that. So this is what the cone looks like. So we might have to fix that. No? So that's not the final answer. This is the answer for this entire thing. This entire thing, total surface area is 27 pi. Why is this thing keep on moving here? I don't want to. Okay, whenever I write, it goes the other way. All right. So everything together, that means the area of the curved part and the area of the base of that cone. You remember the cone is like this, isn't it? And then the base here in front. Right? So that means Since you've got the total, they want only the curved part that curves around the circle. You'll take the 27 minus the area of the circle, which is given by pi r squared, right? So your r here for your circle is also 3. So you will now say your 27 pi minus your pi, are we together? And your radius here will be 3 squared. So in actual sense, it's 27 pi minus your 9 pi. That is why this will not be part of that, no? Okay, so your answer is just 18 pi. Isn't it? So your 18 pi, multiply 18 with your pi, what does it give you? This or 56 or 56.5. That's your area. So this can be that centimeter squared or this. So if you have this and it's marked wrong, because it's wrong here on our map, we got the total wrong. Then we must come, just make a mark and then we rectify that. Louis is smiling, you have it right. You'll get your 2 marks. Okay, so thank you very much for picking that up. We must always read these things very carefully. Né? Okay, so that part is okay. Are we fine? Then we move over to coordinate geometry. Woo, this was not easy. No, not for most of us. Who scored full marks here? In question 13. It's out of 11. Who's got 10 out of 11? 10 out of 11. Nice. 9. Good. 8. Yes. Nice. All right. So, guys, what do we have here? We've got 2 points. I even want you, if you've got a nice grade paper, to even go and draw the points. Yeah? Especially practicing. You are done studying. You know you are fine. Go and get your 1. Go and get there where your 7 is, put the point there. Go and get your 5, go and get your 6, so your line might look like that. Nah? Join with a straight line. So you've got your A there. This will help you to picture. Find the gradient here. So your A is your 1 and 7. Your B now is your 5 and 6. How do I change on my Y and how do I change on my X? So my Y change will be this to that. So if I say 7 minus 6, and then my X change would be 1 minus that. So I say 1 minus 5. On top I have 1. And here I've got negative 4, isn't it? So it will be a negative 1/4. Is that correct? Let me confirm with what's my answer? Yes. So you have that. Or some of you might have put it as 0.25. Also okay. You put it as a decimal. Changing Y, guys. We've done this thing so many times. Yeah? So rewrite this equation in this form. How do we go from that equation to this? Remember, now you've got the equation y is equal to 1/4x plus c. We don't know the c yet, but we can use any of those 2 points, either A or B, to find c. So what do I mean? If you use A, you use the y of A and the x of A, substitute them, and then the only unknown would be the c. Even if you use B for 5 and 6, they will still give you the same answer. It doesn't matter which one you use. Which one do you want to use? If we use the first one, it will be 7 equal to 1/4, negative 1/4, and then 1 over here, plus then your C. So what do you get here? This will just be the same thing. So it will now be 7 plus then your 1/4 is equal to your C. What do you get if you do this? 7 plus that, 7 1/4. If you put it into, what do you get? Yeah, you can put it as a fraction or whatsoever, all together. Or even like now, I could put it as, you can even have it like this and add it, multiply by 4, multiply, then I will get 9/4, isn't it? Yeah, so now you have the complete one. Y is equal to a negative 1/4, and then it's a positive one, eh? Positive 29/4. And then you now need to put this in what? In that form. Are you following? So we want it in linear form. So we multiply by 4 throughout, isn't it? Are we together? So when we take that whole thing and we multiply by 4, so 4 times that would be 4y. Is that, are you following, guys? Okay, and what else do we have? This will now be equal to what? And this will now be equal to, because this will cancel negative x, isn't it? Are we following? And then here, that's 29. This is in its linear form, but we want it in what form? To be equal to 0, like this. Are we together? All right, and you see this, it's like I want that to be positive. Yeah? So it's like you can take everything to the right hand side. So if you do that, it will be x, which becomes positive, plus then your 4y minus your 29 is equal to 0. Like taking that becomes a positive, taking it over becomes a negative over here. So this is the right answer. I've got it in that form of that, plus then my 4b is there, and then my constant is there equal to 0. So the final answer there is what we have over here. This answer over here. We must have it like that. Yes. To A, it passes through only A, so you can only use A. If it passes through both B and A, if it was maybe just a straight line, then you can use both. You understand? I think the next question will clarify that a little bit. Okay, so what she's asking is, here we are explicitly told that this line, remember, that's why I say, do your rough sketches, man. Use a different color. So the rough sketch, we had something like this, man. So we had A over here, and we had B over here. Now they are saying, Lucico, don't write on my board, please. Okay, thank you. Right, so now we have this point. Now you've got the line AB that intersects with this line here. Are we together? At point C. So this line has a line that intersects with point C. Now find the coordinates of C. How will you do that? It intersects with the line. How will you find the coordinates of C? Now you can see that that line, since it has a negative gradient, could be something like, I don't know, like to that direction or what. Yeah? Let's just say it intersects. So this line is y is equal to something. This line is y is equal to something, right? So if you take this as your first line and the second line, at the point of intersection, the y1 was equal to the y2. Are we following? So you could take this line that you have there, which we established to be negative 1 over 4x, and what was our c? And we get the c as well, then 29 over 4. Okay, that will now be equal to this line over here, which is your minus x plus your 20. Are you following? So this will now help you to find your x. Make x the subject of the formula. Once you find that x, you use the same x either in that line or in the other line to find your y. Are you following? Are we together? So now, if that is the case, from there it's just algebra, guys. From there you just follow algebra. I can't really go through that one again, yeah? Because it's quite lengthy. What I have here is group the x's together. 1 over 4x. Take the x over, it becomes a positive x, and then you already had the 20 minus now your 29 over your 4. Just give me 29 over 4, giving me this number, man? Minus 51 over 4. If I simplify that, and then if I add this guy to that, because they are like terms, it gives me negative 3 over 4x. Now you have this one, you want to solve for x. You divide by negative 3 over 4 so that it can cancel out. You also have to divide by negative 3 over 4 here. So if you do that, my x is equal to 17. Are you following? So the x here will be 17 because the coordinate will always list your x and then your y. And then for you to find your y, you can go back to the equation. So I use this same equation that they gave me there, this one here. So my y will now be minus 17. Wherever there's x, I put my 17 that I found here, plus then the 20, which gives me 3. So the coordinates is 17 and 3. Is that making sense? Which one? This is negative here. The equation, The general equation says y is equal to negative x plus 20. So I'm coming to substitute wherever there is x. Let's just substitute the x. That negative is part of it. You understand? If this x 17 was a negative 17, then you would say negative times negative. You understand? Please just always put your brackets around it. It's a common mistake even when we're getting the change in y and the change in x. We say y2 minus y1 over x2 minus x1. Please put these guys in brackets because sometimes if this was negative, we tend to just put one negative here. It's a very common mistake. Yes, Maria? Did you get the same coordinate? How did you do it? Oh, yes, it's fine. Yeah, you can use the two equations. So what you did is, instead of equating them to one another, she said now minus x plus your 20 was equal to y. And then I had my 1 over 4x plus then my 29 over 4 is equal to y. So if you've got two equations there, one equation there, the second one, and she put the variables on one side, the constants on one side, and solve it simultaneously. It's still fine. You'll get the same answer. You get the x values and you'll get that. That's the beauty about math. You can solve in different manners. Okay. Yes. The question? That is how we calculated our C. Remember our C, we were just having y is equal to negative 1 over 4x plus C. So we were taking your A and we're taking your B. So you could use any of the points. The A was your, I think it was 1 and 7. So if you put the 7 in here and the negative 1 over 4, and then you put your 1 in there plus that. If you bring this over to this side, that's how you get your 29 over 4 and your C. If you solve 7 plus, of course, 29 over, what was that? 7 plus, yeah, you can also have it as a decimal, it's fine. It's the same thing. Yeah, okay. So, yes, so we have the last part of that question. So the last part, what's my time, guys? Huh? It's quarter past already. 1 minute, sir. 1 minute. So let me just quickly run. Right, now we need to listen very carefully. Here they are telling us that the equation through which this line is going only passes through A, which is perpendicular to that. So remember, look here, if you have A and B, that line only passes only through A, and it's perpendicular to A. Now remember, the gradient that you are having here as your first gradient was a negative proportion, right? And then this gradient, your M2 is unknown. But I know since they are perpendicular, since they are 90 to one another, I don't like that thing moving there. Okay, so since they are 90 to that, we said that the gradient 1 multiplied, the products of these gradients must give me a negative 1. That's what perpendicular lines mean, right? So, are you having this gradient? Yes, I have that gradient, but I don't have this one. So I can have that gradient to find it, right? So I can have 1 over 4, and then my M2 equal to a negative 1. Divide by 1 over 4, so they can cancel out. I also need to divide this side by a negative 1 over 4. Are we following? So if I do that, then my gradient 2 was 4. But equal to 4. But it's not done. They want me to get the equation. So my equation is not complete. Y is now equal to 4x plus C. Are we together? Now at this point, Luis, I can only use point A because it only passes through point A. It doesn't pass through the line. Are we together? So my point A was having coordinates of 5 and 6, isn't it? So now at the X, I put 5. Pardon? Oh, so 1 and 7. Oh, this was point B. Sorry. 1 and 7. So I put my 7 for my Y, 4 and my 1 over here, plus then my C. So this is 5, isn't it? And this is 7 plus then my C. Take the 5 over, 7 minus 5 will give me my C, which is 2, isn't it? All right, so my C will be equal to 2. So if that happens, then I would say my Y will now be equal to my 4x plus then my 2. This is the equation of the line that is perpendicular to line AB and B. Why do I have 3? Oh, it should be 4. Sorry, yes, that's what I'm saying. I'm having a 3 here. 4. Yes. In a calculating error then. Yo. To the midpoint. Yes. So it's a very good question. It's asking how do we know that this line is perpendicular to that? It comes down to the point that, remember, if you have line A and line B, and you are told that there's a perpendicular line to the midpoint of line AB. So the midpoint of line AB should be here, which you can get now by saying your x1 plus your x2 over your 2, and then your y1 plus your y2 over your 2. That's your midpoint. So let's say your midpoint now, you get now 2 and 4, for example. So the line that is perpendicular to this point, you first need to find the gradient of that line, M2. That's the way we do it. Because you know the gradient of this line. So that gradient of this line times this gradient of that must be equal to -1. But you have this gradient. So if that gradient was maybe 2, M2 is equal to -1. Divide by 2, they cancel out. So M2 will now have a gradient of a -half. So your equation now will be y is equal now to a -half x plus your c. How do I find my c? I use the midpoint for my x, for my y and for my x. You understand? To find the c, because it only passes through the midpoint. Once I find my c, like we can say now, -half of 2, and then I've got 4 over here equal to my c. This will give me a -1, taking it over the c is 5. So you write it out to say y will now be equal to -half x plus my 5. That line will be perpendicular to that line. So the trick is just find the midpoint, use the midpoint to find the c. Once you find the c, write the complete one. This question is very common. Might come, I don't know. So it's good to know how to do it. Yeah? So when you come back from break, you'll continue with the matrices. After the matrices, it's not a lot of things to do. A bit of trigonometry there. And then you've got statistics, and that's the last one. I think if you want, we are here. So you can still ask the question. Those marks you want to be rectified up to now, just come so we finish it, and then afterwards, when they come, but I can't even so because they are that don't have it now. Maybe if I rest later, I can compile it. Yeah, just got around. Yes. 1 hour. What is the time now? What is the time? 19 past. So let's come back half past, né? So you have a little bit of extra 10 minutes. So I want to half past 3. The break is over at half past 3. That means you must be in class by half past 3. In class, all together. Because that extra 10 minutes.
Sir.
Who has the
Sir.
When did you get the graphic number? No, wait till you get that. No, someone from home number, right?
Sir. Sir.
Oh, sorry guys, this says, go to the green one.
Sir.
Yes, is there a question? We'll just use the same link after an hour. We've got an hour break. Then we'll continue 3:30. Just press on the green one, and then you can quickly say, "It no more." Yeah, more. Yeah, or that all the way off from the screen. No, the more is that. You now have to do the more on the laptop because I wanted to do it. Go with the pencil. Go. Now go off the screen. Off the screen. Now you're on the laptop. Look at your cursor on the laptop now.
Okay. Huh?
More.
More is what?
Down here or not? There are 3 dots down here. No, to the right. End meeting for all. The time is the last end.
Say stop live stream.
No, you should take end meeting. Yeah. Just end.